Okay, you big-headed tater-tot looking freak. You trick me, you stack the odds against me, you threaten my friends, and you insult my robot. Now, I'm mad.
Chat, I think Ren forgot. It's fine, I can read this on my own. Alright. Give me a second. Let me switch to something a little bit more appropriate for music. Get a reset blank. Give me a second. Yeah, let's listen to some cave story. Why not? All right. Hello, chat. I just woke up. Yeah. Turns out 8 AM is a little bit early for me. That's okay though. Okay. So, I need to make this stay on top. Okay. And load the save. Where's the load button? There it is. Okay. So, hello Twilight. Let me double check everything real quick. So I don't know how it's gonna work if, I don't know how the multiplayer works if they load in later. Are they just gonna spawn next to me, or? Guess we'll find out. Wish the streamer would tag me directly. Yeah, you know, we have a tag for that. It's called @notification. If you join us at https://azakata.fun/discord. You know, a little plug. That's not directly. I mean, it still pings you. That's good enough. All right. They'll spawn at original place. Well, I mean, the worst that could worst case scenario, we can just have Rin figure out how to respawn, and then she'll spawn next to me, if anything. Okay, so last time around we got this sweet car. Oh, there we go. How do I switch to third person again? I know we'll figure out last time. See? Ah, there we go. Thank you, Blank. Okay. Now let's get back on the road then. Let me rock. Okay. So where's the road? Here. Okay. The car's still shiny? Yep, it still is. There are 4 debuggers included in the tools: CDB, NTSD, KD, and WinDebug. I'm sure it was I'm sure you had to constrain yourself from saying CBT. Thank you, Crispy. All are based on a single debug engine, implemented in debug.eng.dll, which is documented fairly well in the help file of the tools. Here's a brief overview of the debuggers. CBD, CDB, and NTSD are user mode debuggers based on console user interface. The only difference between them is that NTSD opens a new console window if activated from an existing console, while CDB does not. That really is a mouthful. KD is the kernel mode debugger based on a console user interface. By the way, there are so CDB can actually be used as a lull bin, so you can actually use CDB to load shellcode if you wanted. We've seen it used a few times. I believe it is also documented on Lobin's project. So yeah, you can just tell CDB to load like a CDB encoded shellcode, and it'll just happily load it. Why the funk is that on my screen? CBT loads shellcode? Yes, it sure does. Okay. WinDebug can be used as a user mode or kernel mode debugger, but not both at the same time. It provides a GUI for the user. By the way, WinDebug is kind of annoying to download these days. There are third-party utilities where you can use it to like update WinDebug if you need to, but yeah, it relies on an MSIX remote download now. Kind of annoying. That's fine. Not the worst thing in the world, but I kind of wish they would just, you know, provide us with like a straight up package exe. GUI CVT, yes. The user mode debuggers, CDB, NTSD, and WinDebug, when used as such, are essentially equivalent. Usage of one or the other is a matter of preference. So, the only user mode debugger I've really used most often is 64 debug. I've not used any of the existing Windows ones because they are not the most straightforward to use. Because the commands are basically like one word. And you basically need to reference the manual every time. You're actually studying? I just read the title. Welcome to the stream. We did that 2 streams ago as well. We're just continuing where we last left off. By the way, I'm like barely holding down W. I'm just like pressing W every now and then. Hang on, I can't drink and study it and oh my god. Yeah, this car is really fiddly. Sorry, I missed some streams because I'm not in the same time zone. Gamer. Oh yeah, by the way, these Windows internal streams are always going to be at like around this hour, where it's like hopefully the most accessible to US users, watchers, audience, I hope. I think 8 a.m. or like, I think this like what, 5 p.m. Pacific time or something. Should be late enough in the day for US, I hope. Yes? Crispy, is it late enough for you? Alright, the kernel mode debuggers, KD and WinDebug, when used as such, are equivalent as well. I mean, Central at 7 p.m. Yeah, it seems late enough. Oh, 8 p.m. See? Okay. Oh god. So, to show you how difficult this is, right? I have to control the car, but also whenever I need to scroll, I need to tab out to do it. So there's gonna be a moment where I lose control of the car. Okay. User mode debugging. The debugging tool can be used as such, can be used to attach to a user mode process and examine and or change process memory. Ooh, what was that? There are 2 options when attaching to a process. Invasive. Unless specified otherwise, when you attach to a running process, you are using debug active process window function to establish a connection between the debugger and the debuggee. Why is the music getting scary? This permits you to examine and or change process memory, set breakpoints, and perform other debugging functions. Windows allows you to stop debugging without killing the target process as long as the debugger is attached or not killed. Which fork do we take, guys? Left? Okay. What, right? Alright, chat, I'm gonna need you guys to make a decision. Right? Okay. That just seems to go back to where we were, no? Are you sure? Left with backtrack, go straight. Okay, go straight. This is straight, right? I kind of lost track for a little bit. That was too many intersections. Non-invasive. With this option, the debugger simply opens the process with open process function. It does not attach to the process's debugger. This allows you to examine and or change memory of the target process, but you cannot set breakpoints. This also means it's possible to attach non-invasively even if another debugger is attached invasively. I gotta pee, can we pull over? No. There's no time for us to stop. You can also open user mode process dump files with the debugging tools. User mode dump files are explained in Chapter 8 and Part 2 in the section on exception dispatching. Kernel mode debugging. As mentioned, there are two debuggers that can be used for kernel debugging. A command line version, kd.exe, and a GUI version, windebug.exe. This audiobook is making me sleepy. Can you put on the radio? But if I turn it on, I'm gonna get copyright claimed. And the VOD's gonna get muted. That's no good. Even though I really wanted to put on Truckers FM. Are we there yet? Can we stop for McDonald's? Oh my god, guys. This is a road trip, not a family road trip. Stop at the gas station for sodies? I wish there is one. I gotta pee. Okay, fine. Go pee. We'll stop. Alright, let me know when you're back. Smiley face. I assume that's back. I'm gonna leave you. I went in the car. Oh my god. Go in the ball like a real man. Guys, please. You can perform 3 types of kernel debugging with these tools. Open crash dump, created as a result of a Windows system crash. See Chapter 15, Crash Dump Analysis, in Part 2 for more information on crash dumps. You have games on your phone? Here you go, I've got Minecraft. Have fun with Bedrock Edition on the phone. Which, by the way, apparently you can run Java edition of the game on the phone. Apparently that's a thing. Oh yeah, by the way, if you ever run into like, first of all, I need to stop. How do I sleep again? It's like one of these buttons. Controls. Z for sleep? Yeah, I wish. How do I sleep? I know it's one of these, but V. There we go. Right, as I was saying. So if you ever run into a blue screen, instead of going through the usual, check your antivirus, check your hardware, instead of doing all that, stop wasting your time. Just put the crash dump, usually located under Windows /mini dump or app data crash dump or something. I forgot. You can look it up. Instead of doing that, put the crash dump into WinDebug. It'll tell you exactly what happened. If it's a regular non-hardware related crash, okay, calm down. What's wrong with this car? Yeah, put the crash dump into WinDebug. It's gonna tell you exactly what happened. If it's a hardware failure, it's gonna be super obvious because there's not gonna be any what's it called? Stack trace. Yeah. So if it's a actual software related stuff, oh, great! I don't know what happened. Awesome. Game's freaking out again. All right. Tire go burr, apparently. How do I stop the ignition again? Ah, whatever. Don't read and drive? Yeah, apparently not. Okay, my left... my A key is stuck again. We had this happen the last time as well. I might need to reload. So, save. Main menu. This one. There we go. Okay. So, yeah, as I was saying, if anything ever happens, just wasn't there supposed to be like a rim or like the little thing inside? Oh, okay. I guess never mind. There. Okay. I think that's the back, the bumper or something. Right, as I was saying, yeah, put the crash dump. This includes things like either a regular user process dump or a kernel crash dump, aka blue screen. Just pop that thing in the game, in the WinDebug, and it's gonna tell you exactly what happened. Connect to a live running system and examine the system state, or set breakpoints if you're debugging device driver code. This operation requires two computers: a target, the system being debugged, and a host, the system running the debugger. The target system can be connected to the host via no modem cable and IEEE 1394 cable. Is that a FireWire? I forgot. A USB 2.0, 3.0 debugging cable, or the local network. The target system must be booted into debugging mode. You can configure the system to boot in debugging mode using bcdedit or msconfig.exe. Note that you may have to disable secure boot in the UEFI BIOS settings. You can also connect through a name pipe, which is useful when debugging Windows 7 or earlier systems through a virtual machine product such as Hyper-V, VirtualBox, or VMware Workstation. By exposing the guest operating system serial port as a name pipe device. For Windows 8 and later guests, you should instead use the local network debugging by exposing a host-only network using a virtual NIC in the guest operating system. This will result in 1,000 times performance gain. Wow, 1,000 times. A Windows system allows you to connect to the local system and examine the system state. This is called local kernel debugging. To initiate local kernel debugging with Windows Debug, first make sure that the I want to go right this time. First, make sure the system is set to debug mode. For example, by running msconfig, clicking boot tab, advanced options, selecting debug, and restart Windows. Launch WinDebug with admin privileges and open the file menu, choose kernel debug on the local tab. And click OK use bcdedit. And choose figure 1-6 shows it. God damn it. I'm trying to read. Alright, hang on. Man, this tire sure pops off a lot. Oh, nope, nope, Okay. You know, something I should have thought about before starting today's stream, you know, if I had woken up earlier, is I should have gotten throat candy. I mentioned that last stream as well. Yeah, I forgot about it again. Well. Figure 1-6 shows a sample output screen on a 64-bit Windows 10 machine. Some kernel debugger commands do not work when used in local kernel debugging mode, such as setting breakpoints or creating memory dump with the .dump command. However, the latter can be done with livekd, described later in this section. So the one in the screenshot is actually a much older version of WinDebug, where it's still using the classic UI. There is shortly after this came out, I believe, there's now a much newer version of WinDebug that looks a lot more modern. It's actually got the Windows ribbon interface, and it's actually a lot more tolerable to look at than this. This looks like This looks like it came out of the Ollie debug era. Once connected in kernel debugging mode, you can use one of the many debugger extension commands, also known as bang commands, which are commands that begin with an exclamation point to display the contents of internal data, data structures such as threads, processes, request packets, and memory management information. Throughout this book, the relevant kernel debugger commands and outputs are included as they apply to each topic being discussed. An excellent companion reference is the debugger.chm help file contained in the WinDebug installation file, which documents all the kernel debugger functionality and extensions. In addition, the DT or display type command can format more than 1,000 kernel structures because the kernel symbol files for Windows contain type information that the debugger can use to format structures. So yeah, WinDebug is clearly very helpful. The problem is I don't use it enough. I only use it to either look at crash dumps or in the very rare instances where I have to use SOS to view really tricky .NET malware. But yeah, I need to use it more. The main reason I don't use it more is because the commands are very confusing. Especially all of them are like abbreviated, as you just saw. For display type, it's DT. Yeah, just try to remember all that abbreviation for like 1,000+ commands or something. I don't know if there are actually that many. Displaying type information for kernel structures. To display a list of kernel structures whose type information is included in the kernel symbols, type DT nt exclamation mark underscore asterisk in the kernel debugger. A sample partial output is shown here. Nt-kernel mp is the internal file name for the 64-bit kernel. For more details, see chapter 2. And yeah, you just type that out and it'll show you the structures. You can also use the DT command to search for specific structures by using its wildcard lookup capability. For example, if you were looking for the structure name for an interrupt object, you could type DT exclamation mark underscore asterisk or wildcard interrupt wildcard. Okay. Then you can use DT to format the specific structure as shown next. Debuggers treat structures as case sensitive and case insensitive. Note that DT does not show substructures, structures within structures by default. To show substructures, use -r or -p switches. For example, using one of these switches, to display the kernel interrupt object shows the format of the list entry structure stored in the interrupt list entry field. See the documentation for exact differences between -r and -p switches. Okay. Hang on, I'm gonna make this turn first before we continue. So chat, I have a backup solution for the lack of Bro Candy. Technically I can order a takeout, have it delivered to me. And I'm kind of hungry anyways. We'll do that after we've reached the end of this chapter, which shouldn't be too far longer, I hope. Or maybe page 50 at the latest. The DT command even lets you specify the level of recursion of structures by appending a number to the -r switch. The following example means one level of recursion. The debugging tools for Windows help file explains how to set up and use kernel debuggers. For additional details on using kernel debuggers aimed primarily at device driver writers, see the WDK or Windows Driver Development Kit documentation. LiveKD tool. LiveKD is a free tool from sysinternals that enables you to use the standard Microsoft kernel debuggers just described to examine the running system without booting into debugging mode. This approach might be helpful when the kernel level troubleshooting is required on a machine that wasn't booted into debugging mode. Certain issues might be hard to reproduce reliably, so reboot with the debug option enabled might not readily exhibit the error. You run LiveKD just as you would with WinDebug or KD. LiveKD passes any command line option you specify to the debugger you select. By default, LiveKD runs the command line kernel debugger, KD. To have it run WinDebug, use the -w switch. See the help files of the LiveKD switches, use the --? Switch. LiveKD presents a simulated crash dump file to the debugger so it can perform any operation in LiveKD that are supported in a crash dump. Because LiveKD relies on physical memory to back the simulated dump, the kernel debugger might run into situations in which data structure are in the middle of being changed by the system and are inconsistent. Each time the debugger is launched, it starts with a fresh view of the system state. If you want to refresh a snapshot, enter the Q command to quit the debugger. LiveKD will ask if you want to start it again. If the debugger enters a loop in printing the output, press Ctrl+C to interrupt output and quit. If it hangs, press Ctrl-break, which will terminate the debugger process. I've never heard anything that uses Ctrl-break as a hotkey. LiveKD will ask whether or not you want to run the debugger again. Windows Software Development Kit. Windows Software Develop. Can I go up? Up. Slowly. Surely. Up. Okay, we might have to build up the speed again. Okay. Try this again. The Windows Software Development Kit is available as part of the MSDN subscription program. You can also download it for free from that link. Visual Studio also provides an option of installing SDK as part of the VS installation. The version contained in the Windows SDK always match the latest version of the Windows operating system, whereas the version that comes with Visual Studio might be an older version that was current when that version was released. WDK meaning woman Donkey Kong? Yes, precisely. Every time I think of a quote-unquote woman Donkey Kong, I think of that Donkey Kong cartoon. You know, the 3D one? The one where Donkey Kong gives coconut cream pie? Yep, that one. I had it on VHS? No way. I've only seen it through memes on YouTube. Where was I? Besides the debugging tool for Windows, it contains the C header files and the libraries necessary to compile and link Windows applications. From a Windows internals perspective, items of interest in the Windows SDK include the Windows API header file, for example, the include folder within the Windows WTK, and the SDK tools, search for the bin folder. Also of interest is the documentation. It's available online or can be downloaded for offline access. I actually never looked at the documentation offline. I might have to check that out. A few of these tools are also shipped as sample source code in both Windows SDK and MSDN library. Okay, and then another fork, just going this way. Before that, I'll be... Can't sleep yet. Okay. There's a yellow cassette? Wow. That's pretty fitting. I can't see anything. I almost ran into that rock there. Banana. Oh. Okay, I'm not sure what I just ran into. Because I can't see anything. Can I sleep yet? Okay, I can. Sick jump. Wicked. Alright, there we go. Okay. Windows Driver Kit. The Windows Driver Kit, also known as WDK, is available through the MSDN subscription program. Just like the Windows SDK, it is available for free download. The WDK documentation is included in the MSDN library. Although the WDK is aimed at developers of device drivers, it is an abundant source of Windows internals information. For example, Chapter 6 describes the IO system structure, architecture, driver model, and basic device driver data structures. It does not describe the individual kernel support functions in detail. The WDK documentation contains a comprehensive description of all the Windows kernel support functions and mechanisms used by device drivers in both tutorial and reference form. In addition to including the documentation, the WDK contains header files, in particular ntddk.h, ntifs.h, and wdm.h, that defines the key internal data structures and constants as well as interfaces to many internal system routines. These files are useful when exploring Windows internal data structures with the kernel debugger, because although the general layout and content of these structures are shown in this book, detailed field-level descriptions, such as size and data types, are not. A number of these data structures, such as object dispatcher headers, wait blocks, events, mutants, semaphores, and so on, are however fully described in the WDK. The biome just changed again. Biome. If you want to dig into the IO system and driver model beyond what's presented in this book, read the WDK documentation, especially the kernel mode driver architecture design guide and kernel mode driver reference manuals. You might also find useful Programming the Microsoft Windows Driver Model 2nd Edition by Walter Winey. Is that how you say that? Winey? Winey? And Developing Drivers with the Windows Driver Foundation by Penny Orrick and Guy Smith. There are people actually out there named Guy. Like Guy Fieri. Sysinternals tools. Many experiments in this book use freeware tools you can download from Sysinternals. Mark, the co-author of this book, wrote most of these tools. The most popular tools include Process Explorer and Process Monitor. Okay. And our rear view mirror dropped off. There we go. Note that many of these utilities involve the installation and execution of kernel mode device drivers and thus require administrator or elevated privileges. Although some of them can be run with limited functionality and output on a standard or non-elevated user account. Because these sysinternal tools are updated frequently, be sure you have the latest version. To be notified of tool updates, you can follow the sysinternal site blog, which has an RSS feed. They do? For a description of all the tools, a description on how to use them, and case studies of problem solved, see Windows Internals Administrator Reference by Mark and Aaron from 2011. For questions and discussions on the tools, use sysinternals form. Did the biome just change again? Sounded a lot rocky again. Conclusion. This chapter introduced key Windows technical concepts and terms that will be used throughout the book. It also offered a glimpse of many useful tools available for digging into Windows internals. Now you're ready to begin your exploration of internal design of the system. I almost ran into that rock again. Beginning with an overview of the system architecture as key components. Alright, and that was chapter 1. Now, before we go on, I want to order takeout, because I need that road I don't even know if I can actually order something like that through the delivery app. Let's see. By the way, it's kind of annoying that I don't know about you guys and your delivery services, but here, Food Panda and what is it? Uber Eats. You can only order like you can only get stuff delivered from one place. There are times where I'm just like, I want to order more than this thing at one specific place. Okay, let's see. Is there a 7-Eleven around here that can get delivered? That's a no. Okay. What do you mean KFC is open? It's like 8:52. They're open this early? I need something that I can have along with a drink, because clearly it looks like 7-Eleven is not an option here for some reason. They must have stopped doing delivery, right? Let me click on convenience store. Yeah. Oh, no. Okay. Okay, no, I see convenience store. Okay. Okay. Can I get through candy? I don't even know if that's the right term. You guys know what I'm saying, right? Cough drops. Yeah. Okay, yes, I can. Okay. Can I get some food then while I'm here? Hopefully something I can have in one hand while I drive. To get the ultimate driving experience. Okay, yes. Okay. Okay, I'll get a, what does that say? Italian-style chicken thigh with herbs. Wow. Okay, it doesn't even say what... Okay, so like it's like a little wrap thing. Wrapped in egg. Can I also get something to drink? I mean, I suppose I don't really need one. I already have sparkling water. Ooh, I can get tea. Okay. Okay, screw it. Let's get tea or whatever. Oh, I can't choose what sugar level is? Really? Okay, well, that's lame. Never mind then. I'm like a cent off from getting free delivery. This is what I hate about delivery apps, by the way. The fees are insane. And there's gonna be like, oh, you can get it for free shipping if you get to this amount. I'm like, okay, but now I'm just ordering more things that I need. Okay. Is there anything else I can have? It's like a little snack. Give me a second. I promise you we're almost there. How about Joker? Yes. No, I still need to learn. Oh. Ooh. Oh, in that case, whatever. That's good enough. I'll just have to pay that extra $1.50 delivery fee. Damn. Wow, that is expensive. That's like $80. Or, sorry, not $80, $8. Speaking of, let me check the general quick. Okay, it looks like Rin won't be joining us. That's fine. She is exhausted. That's okay. No worries. Okay. Okay, I've got the delivery out. Okay, meanwhile, we can keep reading. Oh, we get the thing delivered. Okay, system architecture. Now that you've learned the terms, concepts, and tools you need to be familiar with, it's time to start exploring the internal design goals and the structure of the Microsoft Windows operating system, OS. This chapter explains the overall architecture of the system, the key components, and how they interact with each other, and the context in which they run. To provide a framework for understanding the internals of Windows, let's first review the requirements and goals that shape the original design and specification of the system. Requirements and design goals. The following requirements drove the specification of Windows NT back in 1989. First being, provide a true 32-bit preemptive reentrant virtual memory OS. I have no idea what the word reentrant means. Run on multiple hardware architectures and platforms. Run and scale well on symmetric multiprocessing systems. Be a great distributed computing platform, both as a network client and as a server. Run most existing 16-bit MS-DOS and Windows 3.1 applications. Meet government requirements for POSIX 103.1 compliance. I have no idea what that is either. Meet government and industry requirements for OS security. Be easily adaptable to the global market by supporting Unicode. To guide the thousands of decisions that had to be made to create a system that met these requirements, the Windows NT design team adopted the following design goals at the beginning of the project. Extensibility. The code must be written to comfortably grow and change as market requirements change. Portability. The system must be able to run on multiple hardware architectures and must be able to move with relative ease to new ones as market's demands dictate. Reliability and robustness. The system should protect itself from internal malfunctions and external tempering. The application should not be able to harm the OS or other applications. Compatibility. Although Windows NT should extend existing technology, its user interface and API should be compatible with older versions of Windows and with MS-DOS. It should also interoperate well with other systems, such as Unix, OS/2, and NetWare. Performance. Within the constraints of other design goals, the system should be as fast and responsive as possible on each hardware platform. As we explore the details of the internal structures and operations of Windows, you'll see how these original design goals and market requirements were woven successfully into the constructions of the system. Now, before we continue, we have to make a little brief stop. Alright, chat, we're getting at the abandoned gas station. How do I stop this thing, by the way? Ideally, I turn. I hear him. Let me figure out how to... Nope. Oh. I'm glad he's stuck in there. How do I turn this off? Ah, there we go. What's ticking? I'm a little scared. I have a shovel. I'm not afraid to use it.
One leg here, one leg there. There's going to be blood.
Yep, there's sure is going to be blood. Oh, 7. He died. Okay. Alright, what have we got in here? Bread. I assume that's bread anyways. Eat. Yummy. Bread. Yummy. Alright, anything usable in here? I guess not. Oh, tire. Oh, come on, please. What? No, thank you. Found the gas station. Yeah. There's probably no gas, though. Alright, we can replace the funky front tire that kept popping off. Goodbye. Press the... Yep. Yep. Come on. I want to pick up the entire tire. Nope. Nope. There we go. Does this not go in there? Oh, this might be too big. No. Yeah, it looks like it doesn't go in. Different tire? Damn. Well, alright. Bring regular tire on sports car? Yes. Does it have gas? Okay, it does have gas. So, where's the gas cap again? That's oil. fuel tank? There is. Okay, here we go. $13. No idea what this is. Interesting name. Okay. Yeah, I can pronounce this. This is Jizz on it. Yeah. Not to be confused with different place of un. Get more gas, thank you. Okay, there's more stuff here. Ooh. Hello. Put on. Okay, I think I have a hat now. Yeah, you can barely see it. Ammo. Don't really need a coolant, I believe. I mean, a cooling tank. But I'll put it in the back just in case. Yeah. Oh, wrong button. How do I put it back? How's I found the hat from PZ? No way. Okay. Well, we'll get back to reading once we are done with... Oh, okay, more... Oh, that's oil, not gas. So I guess that goes in the back of, like, the engine? Yeah. Nope, that's not what I meant. Do you have any brush left to clean the tires? Don't believe so. Okay, I'm gonna take the rest with me. Not that we really need it, but why not? For my use at all. To be fair, it might also be on her. Excuse me? There are motorcycles in this game? Well, we don't have the tires anyway, so. Turn on. What do you mean turn on? It's a computer. A spider. Oh, is that what I think it is? It is. Okay. Can't we brush the tire? How do I use this thing? I don't know how to use this thing. Ask Rend? I wish I could. Oh, whatever. Alright, what else is here? Oop. Extra virgin car oil. Very good. Okay. I'll be taking this with me. Okay. I'm gonna need to sleep soon. I can barely see anything. I love how the light is different color when I use a different flashlight. Ooh. Put on. Oh my god, it tints your vision as well. Oh, I love this track. Class Battle, classic. I mean, this looks like it's the same size, right? Surely this will go on. Oh, yep, it goes on. All right. Let's take a nap. Okay, on second thought, I'm not sure if I like this. How do I take this off? I'm also locked into the this view mode. How do I? Man, this game's controls a little confusing. I'm locked in. Yeah, apparently. Oh, that's not what I meant. Reset. Look up, look down. Recenter. Map view. Change camera. Oh, it's... Oh, okay. What? What? Okay, at least I figured out how to take that off. Let me try reloading. That's the fastest way to fix things, right? Yeah, there we go. Okay. Let's get back on the road. Where were we? As we explore the the details of internal structures and operations of Windows, you'll see how these original design goals and market requirements were woven successfully into the construction of the system. But before we start that exploration, let's examine the overall design model for Windows and compare it with other modern operating systems. Operating system model. In most multi-user operating systems, applications are separate from the OS itself. The OS kernel code runs in a privileged processor mode, referred to as kernel mode in this book, with access to system data and to the hardware. Application code runs in non-privileged processor mode, called user mode, with a limited set of interfaces available, limited access to system data, and no direct access to hardware. When user mode program calls a system service, the processor executes a special instruction that switches the calling thread to kernel mode. When the system service completes, the OS switches the thread context back to user mode and allows the caller to continue. Windows is similar to most Unix systems in that it's a monolithic OS in the sense that the bulk of the OS and the device driver code shares the same kernel mode protected memory space. This means that any OS component or device driver can potentially corrupt data by being used by other OS system components. However, as you saw in Chapter 1, Concept and Tools, Windows addresses this through attempts to strengthen the quality and constraint of the provenance of third-party driver through programs such as WHQL and enforcement through KMCS, while also incorporating additional kernel protection technology such as virtualization-based technology, security, and the device guard and HyperGuard features. By the way, yesterday I learned the fact that apparently you can load pretty much any system driver that has revoked cert slapped on top. So the only realistic way you can go about blocking such drivers is by only allowing WHQL drivers, which is something that is mentioned in the last chapter of the book as well. But yeah, not a great solution because not all drivers are WHQL certified, unless you're running on a system server where everything is like heavily regulated. Although you'll see how these pieces fit together in this section, more details will follow in Chapter 7, Security, and in Chapter 8, System Mechanisms, in Windows Internals Part 2. By the way, the delivery is here. I'll pick up in a little bit. Like, it's placed at the front door, so it's fine. All these OS components are, of course, fully protected from errant applications, because the applications don't have direct access to the code and data of the privileged part of the OS, although they can quickly call other kernel services. This protection is one of the reasons why Windows has a reputation for being both robust and stable as an application server and as a workstation platform, yet fast and nimble from the perspective of core OS services, such as virtual memory management, file I/O, networking, and file and print sharing. The kernel mode components of Windows also embody basic object-oriented design principles. For example, in general, they don't reach into one another data structures to access information maintained by individual components. Instead, they use formal interfaces to pass parameters and access and/or modify data structures. What the heck is that? Is that another gas station, but like not abandoned? I hear him. Hello? Hello, buddy.
This is mine.
Aha, get wrecked. Ooh. Attach? Oh, dude. Dude. Do we have a rear view mirror? Oh. G. Hang on. Not what I meant. Yeah. I don't know what that is, but it looks like a little Minecraft figure, but cool. It's someone's Minecraft figure, I guess. Huh. Hello, white bear. A whole slab of meat. Okay, so I saw the, what do you call this part of the tire? Rim? Where is it? This thing. Can I do this? Oh, okay. Woo, there we go. That's honestly looks more like bicycle. No, it is bicycle. You can bike in this game? No way. Milk? In that container? Really? Okay. Yummy. Put that in back there as well. Why not? Yes. Okay. Yeah, that's what I'm talking about. If you squint enough, it looks like Teto. You have to really squint. I mean, vaguely. She's missing a twin drill, though. Okay. I should probably switch to something else that's not my shovel. Okay, I guess that's it. I don't know what this is. Crank. Oh! It's a music box. No way. Okay, I'll take that. Sure, why not? We're getting all sorts of trinkets back there. Alright, I'm gonna run downstairs real quick, get the delivery. Be right back. Alright, chat. I've obtained food and yogurt and cough drop, most importantly of them all. Oh, guess now it's a little break time while I have this food. How are we doing tonight, chat? You know, maybe I should mute the mic. Having PZ doing stuff? Like what? Mail crates. Mail crates get 80 space instead of 40. You know, speaking of crates near the fridge. They're basically filled up. We need another one, or milk crates. Replacing wood crates in the kitchen. Yeah. That'd be great. I wonder how much that would be if you could do Tetris in the milk crates. We have worms in the fridge downstairs. Okay. Dick curl, shovel. You get worms. Okay. We started Christmas recently, so chaos. I guess you live in the southern hemisphere then. No, EU, but wouldn't it be like spring? Spring? Or even Christmas? Enjoying the quietness of night. Sure hope so. It's the other Christmas. Probably confused words because all of them are the same. I'm still very confused, but sure. I've got a bottle of blueberry yogurt, and the blueberry part is like stuck at the bottom of the bottle. We have Jesus being born. You know, we died. And the resurrect part. I'm not familiar enough with the Christian culture, so I still don't know what exactly. Maybe Easter is what you're saying. I think. Okay, that makes sense then. Sounds like people are drilling stuff outside. I keep mistaking that as like cat meowing. All right. Give me a second. Okay, I have finished my food. Now, the most important part of this delivery I got like a whole bag. Should be enough for this stream. And next, hopefully, I was like, this is a lot. How many is in here exactly? Oh, it doesn't say. It only says 80 gram. All right, we'll have them right now. Not sure how well I can speak with little throat candy in my cheeks, but we'll just call everything that to celebrate that and add occasion. Like I vaguely know what you mean. Okay, let's get back to the road. Did we find an alien yet? Oh, beat up a zombie. And we found someone's OC, apparently. Minecraft OC. Okay. Despite its pervasive use of objects to represent shared system resources, Windows is not an object-oriented system in this in the strict sense. Oh yeah, by the way, Crispy, we just had food. I got delivery. Alongside that, I also got a throat candy. So hopefully my throat won't be dying as much this stream. Most of the kernel mode OS code is written in C for portability. The C programming language doesn't directly support object-oriented constructs such as polymorphic functions or class inheritance. Therefore, the C-based implementation of objects in Windows borrows from, but doesn't depend on, features of particular object-oriented languages. We got someone in YouTube chat. Well, I'll be chilling a bit, also studying for SailPoint IDP IGA stuffs. Maybe we merge on the same knowledge gain and miles on the road. Sure, hope so. Oh, what's for food? I got a little. So think onigiri, but instead of seaweed, it's egg. Little rice ball, but like also not a ball. It's more like a slab. There isn't really a name for it, because it's also just called rice ball or onigiri. It's not. Yeah, I guess tamago giri would be the closest representation. Yeah, egg balls. Egg and ball torch. All right, Crispy. Shut up. Okay. Let's see what's over here. Don't know what that is. That's a huge well. Save? Do you think we can, Oop. Jump in the well? Wow. Is that a fridge? Yeah, how do I get out? I don't think I can get out. Well, I'm glad I saved. Okay, let's see what's inside. Oh, proud of you, thank you. Also, thank you for the follow, Kasami. Yeah, you were in YouTube chat earlier. What is this? No idea. How much gas is in this? Oh, 10 liters. Ooh, that's a lot. Okay. I need to switch out this shovel. You go in the back. If I drink 10-liter soda, do you think I'd feel bad? Yes. Do not. Wow, we are stocked up on gas and oil. Okay. Mostly YouTube main, but I'm chilling here. Yeah, it's fine. Thanks for stopping by. Also, yeah, let's get back on the road so we can keep reading. Which way do we come from? This way? We're going to? Okay, architecture overview. With this brief overview, okay, it's kind of hard to speak when there's a big piece of candy in my mouth. With this brief overview of the design goals and packaging of Windows, let's take a look at the key system components that make up its architecture. A simplified version of this architecture is shown in Figure 2-1. Keep in mind that this diagram is basic, it doesn't show everything. For example, the networking components and the various types of device drivers layering that are not shown. Ow. Give me a second. I need to open the... Oh, God. Okay. Man, this really makes it extra challenging. Because I have to open the bottle while I'm falling down the cliff. Okay. So there's the diagram. You can see that. So there's user mode and kernel mode, and then there's also an additional kernel mode in hypervisor context. So, as far as I know, when you use the Type 1 hypervisor, the system runs in parallel. The quote-unquote child partition runs in parallel with this root partition system. So when you have a VM in hypervisor 1, you literally have another system just running at the same time on the same hardware instead of running everything in guest mode. Are we sure we should go this way? This looks like it's wrapping around. Maybe let's try this other way. Yeah, let's try that way. But yeah, kernel mode, you can see there's the hardware abstraction layer, the kernels, the device drivers, windowing and graphics, that's handled by DWM. And user mode, which everything goes through the NTDLL at the end, and with everything on top. In Figure 2-1, first notice the line dividing the user mode and kernel mode part of the Windows OS. The boxes above the line represent user mode processes, and the components below the line are kernel mode OS services. Okay, there's another stop. Why is it on this strange elevated land? Can you put Subway Surfer on screen? No, we're here to study, Crispy. We can't... You must focus. 106 miles to Chicago. We got full tank of gas, half pack of cigarettes. It's dark, and we're wearing sunglasses. I assume that's a reference to something. Movie, yes. A classic. Why is it lit up? What's the switch? I know that's like a trailer, but still. Okay. Anything useful here? Not really. A coolant tank? Low. Thing? Might have to flip this over. Does it even fit in this? No, it doesn't even fit in this wheel. That's lame. Okay, it's not. I thought it was going to be another well. It's not. 0.5 liter of gas. Sure, you know what? I'll take it. I'm gonna close that. Okay. Okay, let's get back on the road. As mentioned in Chapter 1, user mode threads execute in a private process address space. Although while they are executed in kernel mode, they have access to system space. The system processes, service processes, user processes, and environment subsystems each have their own private address space. A second dividing line between kernel mode port A second dividing line between the kernel mode parts of Windows and the hypervisor is also visible. Strictly speaking, the hypervisor still runs on the same CPU privilege level as the kernel, but because it uses specialized CPU instructions, also known as VT-X on Intel, SVM on AMD, it can both isolate itself from the kernel while also monitoring it and the applications. For these reasons, you may often hear the term ring -1 thrown around, which is inaccurate. Yeah, that's a bit of a silly term to use. The four basic types of user mode processes are described as follows. User processes. These processes can be on top of these following types. Can be one of the following types. Windows 32-bit or 64-bit. Windows apps all running on top of the Windows runtime in Windows 8 and later are included in this category. Windows 3.1 16-bit, MS-DOS 16-bit, or POSIX 32-bit and 64-bit. Although, note that 16-bit application can only be run on 32-bit Windows, and POSIX applications are no longer supported as of Windows 8. This looks like an interesting biome. Service processes. These are processes that host Windows services, such as Task Scheduler and Print Spooler services. So these are typically what you call SVC hosts. Watch out, someone threw a rock. Ow. Sip. Wow, that rock sure that sure was a helpful one where it contained liquids that I can drink. Thank you for the substance that what's the word I'm looking for? Sustenance. That's it. Ooh. I heard something just leak back there. Services generally have the same requirement that they run independently of user logons. Many Windows Server applications, such as Microsoft SQL Server and Microsoft Exchange Server, also include components that run as services. Chapter 9, Management Mechanism, and Part 2 describes services in detail. System processes. These are fixed or hardwired processes, such as logon process, the session manager, that are not Windows services. That is, they are not started by the service control manager. I'm thinking we take the right. How do we know we're not circling around back to where we were, by the way? These environments are nice. Yeah. Compared to the stable version of the game, we're currently running on beta. These environments are very nice. I believe these are only in the beta, or in this quote-unquote newer release. Environment subsystem server processes. These implement part of the support for the OS environment and or personality presented to the user and the programmer. Windows NT originally shipped with 3 system environment subsystems: Windows, POSIX, and OS2. However, the OS2 subsystem last shipped with Windows 2000, and POSIX last shipped with Windows XP. The Ultimate and Enterprise editions of Windows 7 clients, as well as all of the server versions of Windows 2008 R2, include support for an enhanced POSIX subsystem called Subsystem for Unix-Based Applications, SUA. The SUA is now discontinued and no longer offered as an optional part of Windows, either client or server. Note: Windows 10 version 1607 includes a Windows subsystem for Linux, WSL, in beta state for developers only. However, this is not a true subsystem as described in the section. This chapter will discuss WSL and related Pico providers in more detail. For more information about Pico processes, see Chapter 3, Process and Jobs. I believe the information about WSL in this version is very outdated because WSL 1 and WSL 2 have very different architectures. And when this book came out, it was still in like the early stages of WSL 1 development. Are you going as fast as you can? Just floor it? Dude, I floored it. It's gonna... We're gonna run into things and be blown out of the window. I'm like occasionally holding down W. This is why we don't go fast. We're gonna spin out of control. In Figure 2-1, notice the Subsystem DLLs box below the Service Processes and User Process box. Under Windows, user applications don't call the native OS services directly. Rather, they go through one or more subsystem dynamic link libraries, or DLLs. I feel like we're circling around a little bit. The role of subsystem DLLs is to translate a documented function into a more appropriate internal and generally undocumented native system service calls implemented mostly in ntdll.dll. This translation might or might not involve sending a message to the environment subsystem process that is serving the user process. Ooh, was that a mansion over there? We'll have way more downtime from the road if we floor it. Yeah. Okay, we're just gonna go check out this mansion real quick. This is lagging my game a little bit. Okay. Alright, I have a shovel. Not afraid to use it. Anyone here? Is there a hole in there? Oh, hello. Goodbye. I hear more of them. What is that? Ooh. Okay, engine, we'll take that. I got is a box of shit. Really?
To this place,
Ooh, license plate.
I don't understand it. Is this the world? I live in this world. I had a
Hello?
I really miss my cat. I love eating cat.
Oh, there's more of them. There we go. Okay. Ooh, a door. Okay, I just kind of want to take this engine, if possible. Okay. See if there's anything else here. Ah, yes, a traffic cone inside the fridge, of course. Let's take a nap here. I can barely see anything. Well, they're having quite a diet, huh? They've got shit. They've got foot. They've got biscuit. What a gourmet experience. I can barely see anything. Oh, is that a headlight? That's a headlight. Huh. I mean, I suppose we don't really need it, but might as well take it. Oh, hello. Goodbye, blow up doll. Had a good run. I don't really need the gun. My inventory's full anyways. What that switch does. What is this? Oh, it's a BB gun thing, I guess. Wow. What a peak entertainment. Just sit down and stare at the painting.
This is
Oh.
my place.
Goodbye. Can I break this open? I guess not. Okay, more Commodore. Or whatever that is. Anyone here? Oh, it's just more flashlight. More guns. Bars of gold. I don't know if that bar of gold does anything. Okay, we're back here. Yeah, well, I guess that's a light switch, but it doesn't do anything. Interesting way outside. Okay. Okay, let's get out of here. This translation might or might not involve sending a message to the environment. Yeah, okay, we've seen that. The kernel mode components of Windows includes the following. Executive. The Windows Executive contains the base OS services such as memory management, process and thread management, security, I/O, networking, and inter-process communication. The Windows kernel. This consists of low-level OS functions such as thread scheduling, interrupt, and exception dispatching, and multi-user synchronization. It also provides a... any better or worse? It's like vaguely bigger. Sure. It also provides a set of routines and basic objects that the rest of the executive uses to implement higher level constructs. Device drivers. This includes both hardware device drivers, which translates user I/O functions calls into specific hardware I/O requests, and non-hardware device drivers, such as file system and network drivers. The hardware abstraction layer. This is a layer of code that isolates the kernel, the device drivers, and the rest of the Windows executive from platform-specific hardware differences, such as differences between motherboards. The windowing and graphics system. This implements the graphical user interface, or GUI, functions, better known as Windows USER and GDI functions, such as dealing with Windows, user interface controls, and drawing. The hypervisor layer. This is composed of a single component, the hypervisor itself. There are no drivers or other modules in this environment. That being said, the hypervisor itself composed of multiple internal layers and services, such as its own memory manager, virtual processor scheduler, interrupt, and timer management. Synchronization routines, partitions, or virtual machine instances management, and inter-partition communication, IPC, and more. So yeah, the concept of host and guest doesn't exist for the Windows hypervisor, or Hyper-V. Instead of the host guest concept is called root and child partition. That's what they meant by that's what they meant by parenthesis virtual machine instances. Table 2-1 lists the file names of the core Windows OS components. You'll need to know these files names because we'll be referring to some of those file systems by name. Each of these components is covered in greater detail both later in this chapter and in the chapters that follow. So there's the ntOSkernel.exe, that's for the executive and kernel, and HAL, which is the hardware abstraction layer, .dlo, Win32k.sys, the kernel part of the Windows subsystem, the GUI, and HVIX64.exe and HVAC64.exe for Intel AMDs respectively. The .sys files in the System32 drivers folder. This includes the core driver files, such as DirectX, Volume Manager, TCP/IP, TPM, and ACPI support. NTDLL, internal support functions, and system services dispatch stubs to executive functions, as well as kernel 32, ADV API 32, user 32, GDI 32.dll. These are core subsystem DLLs. Before we dig into the details of these system components, though, let's examine some basics about the Windows kernel design, starting with how Windows achieves portability across multiple hardware architectures. Portability. Windows was designed to run on a variety of hardware architectures. The initial release of Windows NT supported the x86 and MIPS architecture. Support for the Digital Equipment Corporation, which was bought by Compaq, which later merged in with HP. Alpha AXP was added shortly thereafter. Although Alpha AXP was a 64-bit processor, Windows NT ran in 32-bit mode. During the development of Windows 2000, a native 64-bit version was running on Alpha AXP, but that was never released. Support for a fourth processor architecture, the Motorola PowerPC, was added in Windows NT 3.51. Because of changing marketing demands, however, support for MIPS and PowerPC architecture was dropped before development began on Windows 2000. Later, Compaq withdrew support for the Alpha AXP architecture, resulting in Windows 2000 being supported only on x86 architecture. Windows XP and Windows Server 2003 added support for two 64-bit processor families, the Intel Itanium IA64 family and the AMD 64 family, with its equivalent Intel 64-bit extension technology, also known as EM64T. These latter two implementations are called 64-bit extended systems, and this book are referred to as x64. However, how Windows runs 32-bit applications on 64-bit is explained in Chapter 8 in Part 2. Additionally, as of Windows 2008 R2, IA64 systems are no longer supported by Windows. I feel like we're going back the same way, honestly. I want to go back real quick. I want to go that way, perhaps. Let me take a turn. Additionally, okay. Newer versions of Windows support the ARM processor architecture. For example, nice flip. Wow, okay. I'm surprised nothing flew out. Newer editions of Windows support the ARM processor architecture. For example, Windows RT was a version of Windows 8 that ran on the ARM architecture, although that edition has been since discontinued. By the way, Windows RT, if you have it, install Raspbian on it. It actually makes for a great IoT device. Windows, not so much, because you can barely run anything on that thing. I believe that's mainly because many of the APIs are just straight up not available. For example, I believe virtual lock, one of the most basic core pillars of many applications, I believe it's not usable on Windows NT. So that's also why you can only run like so many different versions of those applications on Windows RT. You know, aside from it being ARM and all that. Windows 10 Mobile, the successor to the Windows Phone 8.x operating system, runs on an ARM-based processor, such as Qualcomm Snapdragon models. Windows 10 IoT runs on both x86 and ARM devices, such as Raspberry Pi 2, which uses an ARM Cortex-A7 processor, and Raspberry Pi 3, which uses the ARM Cortex-A53. So, you know, speaking of Raspberry Pi, right? I recently tried to migrate my Gatebox digital figure stuff to using Raspberry Pi. The only Pi I have is Pi 3. Yeah, I have not gone out and bought any new Pi hardware in a long while. So the Pi is actually pulling double duty. It's actually running as running a very specific network server on it, and also, yeah, currently it's also playing the files for the Gatebox digital figure, so they're video files. I have to install Kodi on it, and well, it's my first time using Kodi. Apparently, Kodi can run about a desktop manager, or windowing manager, or desktop environment, whatever you guys call it on Linux. Like, I know those are three completely separate technologies or concepts. But yeah, Apparently, you can just run that, and I think in the back end it uses Wayland or something. It used to use X, I guess. But like, yeah, just straight up using Wayland as a compositor. Anyways, so initially I was doing it through the Raspbian, or sorry, Raspberry Pi OS's desktop manager, the desktop environment, and yeah, playing video on there was not a good time. First of all, under the Raspberry Pi OS desktop environment, I can't full screen a VLC. VLC will spit out an error about DRM, even though the video file is not DRM protected as far as I know. And it also ran like crap. The video files I had were H.265s, HEVC. Apparently, Pi 3 can't really handle that very well. It's very underpowered. So I had to ditch, I had to ditch using the desktop environment altogether. So I switched over to Kodi. I'd never used Kodi before, and it was a bit of a learning curve as well for that. Not to mention I had to run it on like a very specific resolution. Kodi is not really supported for non-standard monitors. It's pretty much only intended to run on a regular 4x3 or 16:9 monitor. And the one I ran the Pi with is on a very oddball display of, what, 400 by 1280 or something like that. It's like a very long vertical screen. And Kodi had a hard time rendering it because everything is squished together. Anyways, so I switched over to Kodi for playing back H.265 files. It actually ran better, much better, than the desktop environment under Raspberry Pi OS. But the video was still starting. It was still dropping frames. So I ended up having to re-encode the files to H.264 because yeah, they were shipped in HEVC, unfortunately, the video files. And now it's been running okay. Those doesn't run great though. Like, I noticed there's one thing where like it seems to be, the bitrate seems to be lower for some reason when I play it on there. Like I can see blocky artifacts on the file where it's like it's not there if I play on any other regular higher powered devices. I don't know, it's weird. Anyways, that's just a tangent about what I recently did with my Pi. As ARM hardware has advanced to 64-bit, a new processor family called AArch64 or ARM64 may also at some point be supported as an increasing number of devices run on it. Windows achieves portability across hardwares. Across hardware architectures and platforms in two primary ways. By using a layered design. Windows has a layered design with low-level portions of the system that are processor architecture specific or platform specific, isolated into separate modules so that upper layers of the system can be shielded from differences between architectures and among hardware platforms. The key components that provide OS portability are the kernel, contained in ntOS-kernel.exe. Come on, you can do it. I believe in you. Come on. Come on. Come on. Okay. It'd be very beneficial if I had someone to push this right now. Come on. You can do it. Come on. Push it. Yeah. Come on. Okay. Okay, let's sleep first. Let me get out of here, please. Okay, get out of here. Thank you. Apparently, I'm also falling off the cliff while asleep. Okay. Apparently, I can slide off the ramp when I was sleeping. Sure. Okay, I ran out of my sparkling water. I'm gonna get more downstairs. In a little bit. Let's get this car out of here first. I suppose I can't really do it with... Okay, we're gonna have to save first. Just in case. Come on. You can do it. You can do it. Yeah. Come on. Come on. This is me when my scooter runs out of battery. Come on. Almost at the peak. Okay. There we go. We did it, chat. Okay. Now, where was I? The two key components that provide OS probability are the kernel, contained in the NTOS kernel.exe, and the HAL, contained in the HAL.dll. Both of these components are described in more detail later in this chapter. Functions that are architecture specific, such as thread context switching and trap dispatching, are implemented in the kernel. Functions that can differ among systems within the same architecture, for example, different motherboards, are implemented in the HAL. The only other component with a significant amount of architecture-specific code is the memory manager, but even that is a small amount compared to the system as a whole. The hypervisor follows a similar design, with most parts shared between AMD and Intel, with SVM and VTX implementation. Some specific parts of each processor, and hence the two file names on the disk you saw in table 2-1. And by using C. The vast majority of Windows is run using C, some portions in C++. I believe more and more sections of the Windows are using C++ now, especially with the modern rendering of Windows 10 and 11. Assembly languages is only used for those parts of the OS that need to communicate directly with the system hardware, such as the interrupt trap handler, or that are extremely performance sensitive, such as context switching. Assembly language code exists not only in the kernel and the HAL, but also in a few other places within the core OS, such as the routines that implement interlock. Give me a second. Let me get to the top first. Okay. That implement interlock instructions as well as one module in the local procedure call facility. In the kernel mode part of the Windows subsystem, and even some user mode libraries, such as process startup code and ntdll.dll, the system library later explained in this chapter. Symmetric multiprocessing. Multitasking is the OS technique for sharing a single processor among multiple threads of execution. When a computer has more than one processor, however, it can execute multiple threads simultaneously. Thus, whereas a multitasking OS only appears to execute multiple threads at the same time, a multiprocessing OS actually does it, executing one thread on each of its processors. As mentioned at the beginning of this chapter, one of the key design goals for Windows was that it had to run well on multiprocessor computer systems. Windows is a symmetric multiprocessing, or SMP OS. There is no master processor. The OS as well as user threads can be scheduled to run on any processor. Also, all the processors share just one memory space. This model contrasts with an asymmetric multiprocessing, or ASMP, in which the OS typically selects one processor to execute OS kernel code, while other processors only run US user code. The differences in the two multiprocessing models are illustrated in Figure 2-2. So yeah, Windows is on the left, while a quote-unquote asymmetric SMP system is on the right. I guess, okay, left goes down, right goes up. I don't want to go up. Before that, I need to get some water. Give me a second. I'm actually running out of these sparkling water real quick. I'm drinking them far more often than previous bottles. I just see a mosquito in my room. Is that a mosquito? I think that's a mosquito. That's bad news for me. Well, that'll be fun when I have to deal with it. Okay. Windows also supports 4 modern types of multiprocessing system: multi-core, simultaneous multi-threaded, SMT, heterogeneous, and non-uniform memory access, or NUMA. These are briefly mentioned in the following paragraphs. Who made your VRV screen? It's by Boom Boom. I believe it's in the Twitch. I believe it's in my about section down below. But yeah, they made the starting student and the VRV screen. So it's actually good enough that I think I'll keep it for 2.0. Because I like it. It's good. For a complete detailed description of the scheduling support for these systems, see the section on thread scheduling on chapter 4, threads. SMT was first introduced to Windows system by adding support for Intel's hyper-threading technology, which provides 2 logical processors for each physical core. Newer AMD processor under the Zen microarchitecture implement a similar SMT technology, also doubling the logical processor count. Come on, come on, come on. Come on. You got this. maybe we'll go back down. And then we go back up again. Surely. There we go. That's more like it. I hope it doesn't sound too bad when I have the throw candy in my mouth. It's probably not going to sound as clear. I hope that's not too bad. But I kind of need it, so I can actually keep talking. Oh, thank you for a follow. Oh, Annie. I thought you weren't. I thought you were already following. Hello. Each logical processor has its own CPU state, but the execution engine and onboard cache are shared. This permits one logical CPU to make progress while the other logical CPU is stalled, such as after a cache miss or a branch miss prediction. Oh, on YouTube, right? Confusingly, the marketing arc literature for both companies refers to these additional cores as threads. You'll often see claims such as 4 cores, 8 threads. This indicates that up to 8 threads can be scheduled, hence the existence of 8 logical processors. The scheduling algorithms are enhanced to make optimal use of SMT-enabled machines, such as by scheduling threads on an idle physical processor versus choosing an idle logical processor on a physical processor whose logical processors are busy. For more details on thread scheduling, see Chapter 4. In NUMA systems, processors are grouped in smaller units called nodes. Each node has its own processor and memory, and is connected to a larger system through a cache-coherent interconnect bus. Windows on a NUMA system still runs as an SMP system, in that all processors have access to all memory. It's just that node local memory is faster to reference than memory attached to other nodes. The system attempts to improve performance by scheduling threads on processors that are in the same nodes as the memory being used. It attempts to satisfy memory allocation requests from within the node, but allocate from other nodes if necessary. Naturally, Windows also natively supports multi-core systems, because these systems have real physical cores, simply on the same package. The original SMP code in Windows treats them as discrete processors, except for certain accounting and identification tasks such as licensing, described surely, that distinguish between cores on the same processor and cores on different sockets. This is especially important when dealing with cache topologies to optimize their sharing. Finally, ARM version of Windows also supports a technology also known as multiprocessing, whose implementation on such processor is called Big Little. This type of SMP-based design differs from traditional ones in that not all processor cores are identical in their capabilities. Yet unlike pure heterogeneous multiprocessing, they are still able to execute the same instructions. The difference then comes from the clock speed and respective full load or idle power draws, allowing for a collection of slower cores to be paired with faster ones. Think of sending an email on an older dual-core 1 GHz system connected to a modern internet connection. It's unlikely this will be any slower than on an 8-core 3.6 GHz machine because the bottlenecks are most likely caused by human input typing speed and network bandwidth, not raw processing power. Yet even in the deepest power saving mode, such as modern system is likely to use significantly more power than the legacy system. Even if it could regulate down to 1 GHz, the legacy system has probably itself set itself to 200 MHz, for example. By being able to pair such legacy mobile processors with top-of-the-line ones, ARM-based platforms paired with compatible OS kernel scheduler can maximize processing power when needed by turning on all cores. Strike a balance by having certain big cores online and other low ones for other tasks, or run in extremely low power modes by having only one single little core online, enough for SMS and push email. By supporting what are called the more I think about it, the how harder it is to pronounce that word. Heterogeneous scheduling policies. Windows 10 allows threads to pick and choose between a policy that satisfies their need, and will interact with the scheduler and power manager to best support it. You'll learn more about these policies in Chapter 4. Heterogeneous. Right. Windows was not originally designed with a specific processor number limit in mind, other than the licensing policies that differentiate the various Windows editions. However, for convenience and efficiency, Windows does keep track of total processors, total number, idle, busy, and other such details in a bit mask, sometimes known as an infinity mask. That is the same number of bits as the native data type of the machine, 32-bit or 64-bit. This allows the processor to manipulate bits directly within a register. Due to this fact, Windows systems were originally limited to a number of CPUs in the native order, because the affinity mask couldn't be arbitrarily increased. To maintain compatibility, as well as support larger processor systems... It's hard to start. Hang on a second. Oh. Hang on. Sorry, give me a second. Oh. I dropped something. To maintain compatibility, as well as support larger processor systems, Windows implements a higher order construct called a processor group. The processor group is a set of processors that can be defined by a single affinity bit mask, and the kernel as well as applications can choose which group they refer to during affinity updates. Compatible applications can query the number of supported groups, currently limited to 20. The maximum number of logical processor is currently limited to 640. And then enumerate the bit mask for each group. Meanwhile, legacy applications continue to function by seeing only their current group. Okay. For more information on how exactly Windows assigns processors to group, which is also related to NUMA, and legacy processes into group, see Chapter 4. That's a big rock. Alright. Let's stop here for a moment and sleep. As mentioned, the actual number of supported licensed processor depends on the... What are you guys doing here? Hang on. Get back there. Back you go. How much oil do we have? Okay, that's enough. I mean, gas. Oh, I forgot to steal that. Oops. Okay. I can't tell if the handbrake is on or off. As mentioned, the actual number of supported licensed processor depends on the addition of Windows being used. T2. Table 2-2 layer in this chapter. The number is stored in the system license policy file, essentially a set of name value pairs. Under system root, system or service profiles, local service, app data, local, Microsoft WS license, tokens.dat, and the variable kernel register processors. Scalability. One of the key issues with multiprocessor system is scalability. To run correctly on an SMP system, OS code must adhere to strict guidelines and rules. Resource contention and other performance issues are more complicated in multiprocessor systems than in uniprocessor systems, and must be accounted for in system design. Windows incorporates several features that are crucial to its success as a multiprocessor OS. The ability to run OS code on any available processor on multiple processors at the same time. Multiple threads of execution of a single process, each of which can execute simultaneously on different processors. Fine-grained synchronization within the kernel, such as spin locks, queued spin locks, and push locks, as described in Chapter 8 in Part 2, as well as within device drivers and server processes, which allows for more components to run concurrently on multiple processors. Programming mechanism, such as I/O completion ports, as described in Chapter 6 I/O system, that facilitate the efficient implementation of multi-thread server processes that can scale well on multiprocessor systems. Ooh. Okay. I'm surprised nothing fell out. You know, come to think of it, I should probably close the window. Just so nothing falls out. Wicked flip? That was like multiple flips at the same time. The scalability of Windows kernel has evolved over time. For example, Windows Server 2000 introduced per CPU scheduling queues with a fine-grained lock permitting thread scheduling decisions to occur in parallel on multiple processors. Windows 7, I think I'm gonna go this way. Windows 7 and Windows Server 2008 R2 eliminated global scheduler locking during wait dispatching operations. This stepwise improvement of the granularity of locking has also occurred in other areas such as Memory Manager, Cache Manager, and Object Manager. Differences between client and server versions. Windows ships in both client and server retail packages. There are 6 desktop client editions of there are 6 desktop client versions of Windows 10. Windows 10 Home, Windows 10 Pro, Windows 10 Education, Windows 10 Pro Education, Windows 10 Enterprise, and Windows 10 Long-Term Servicing Branch, LTSB. I believe N versions weren't introduced yet at this stage, because wasn't like, hey, we need to make a new version, thanks. I don't believe there have been any other new SKUs though, aside from IoT and IoT Enterprise. And sorry, IoT LTSC. Other non-desktop editions include Windows 10 Mobile, Windows 10 Mobile Enterprise, and Windows 10 IoT Core Enterprise, and IoT Mobile Enterprise. Still more variants exist that target world regions with specific needs, such as the N series. Oh, never mind, there it is. There are 6 different versions of Windows Server 2016. There's the Data Center, Standard, Essentials, Multi-Point Premium, Storage Server, and Hyper-V Server. These versions differ as follows: core-based rather than socket-based pricing for the Server 2016 Data Center and Standard Edition. The number of total logical processors supported. For server systems, the number of Hyper-V containers allowed to run. Client system supports only namespace-based Windows containers. The amount of physical memory supported, actually highest physical address usable for RAM. See Chapter 5 Memory Management for more information on physical memory limits. The number of concurrent network connections supported. For example, a maximum of 10 concurrent connections are allowed to the file and print service and client versions. Support for multi-touch and desktop composition. Support for features such as BitLocker, VHD booting, AppLocker, Hyper-V, and more than 100 other configurable licensing policy values. Layered services that come with Windows Server editions that don't come with the client editions. For example, directory services, PostGuardian, storage space direct, shielded virtual machines, and clustering. So I believe shielded virtual machine is a thing on current versions of Windows client SKUs of Windows now. Table 2-2 lists the difference in memory and processor support for some Windows 10, Windows Server 2012 R2, and Windows Server 2016 edition. For a detailed comparison chart of different editions of Windows Server 2012 R2, see that link. For Windows 10 and Server 2016 edition and earlier OS memory limits, see that link. Although there are several different clients and server retail packages of the Windows OS, they share a common set of core system files, including the kernel image, NTOS kernel.exe, and the PAE version, the NT-kernel PA.exe, and the HAL libraries, device drivers, and the base system utilities and DLLs. Now, there you go. There's the table. I don't know how to go about reading this table, but before you pause. With so many different editions of Windows, and each having the same kernel image, how does the system know which edition is booted? By querying the registry values, product type, and product suite under HKLM, or HK local machine, system current control set, control product options key. Product type is used to distinguish whether the system is a client system or a server system of any flavor. These values are loaded into registry based on the licensing policy file as described earlier. The valid values are listed in table 2-3. This can be queried from the user mode verified version info function or from a device driver using RTL get version or RTL verify version info, both documented in the Windows driver kit. Yeah, there's WinNT, there's LANman NT, and Server NT. A lot of PC progress being done. Sounds good. A different registry value, product policy, contains a cached copy of the data inside tokens.dat file, which why can't I suddenly not pronounce the word? I know how to pronounce the word. Differentiates between the additions of Windows and the features that they enable. So if the core files are essentially the same for the client and server versions, how do the systems differ in operation? In short, server systems are optimized by default for system throughput as high performance applications to servers, whereas the client version, although has server capabilities, is optimized for response time and interactive desktop use. For example, based on the product type, several resource allocation decisions are made differently at system boot time, such as the size and the number of OS heaps or pools, the number of internal system worker threads, and the size of the system data cache. Also, runtime policy decisions, such as the way memory manager trades off system and process memory demands, differ between the server and the client editions. Even some thread scheduling details have different have different default behavior in the two families. The default length of the time slice or thread quantum. See chapter 4 for more details. Where there are significant operational differences in the two products, these are highlighted in the pertinent chapters throughout the rest of this book. Unless otherwise noted, everything in this book applies to both client and server versions. A second. Okay. Experiment. Determining features enabled by licensing policy. As mentioned, Windows supports more than 100 different features that can be enabled through the software licensing mechanism. These policy settings determine the various differences not only between a client and a server installation, but also between each edition or SKU of the OS, such as BitLocker support, available on Windows Server as well as Pro and Enterprise editions of client. You can use the SI policy tool from the downloads available to the book to display many of these policy values. Policy settings are organized by facility, which represents the owner module for which the policy applies. You can display the list of all facilities known to the tool by running SI policy with a -F switch. Now that PD stuff is done, time to drive MC. Sounds good. You can then add the name of any facility after a switch to display the policy value for that facility. For example, to look at the limitations on CPUs and available memory, use the kernel facility. Here's the expected output running on Windows 10 Pro. As you can see, we can do native VHD boot and not dynamic partitioning, virtual memory dynamic partitioning, memory monitoring, etc. As another example, the output for the kernel facility on a Windows Server 2012 R2 Data Center Edition would look something like this, with most of them being yes. Crazy how all these things are running in split seconds in the background when we take things for granted. Yeah, I mean Windows. I know people give a lot of flack for Windows, like understandably so, but I still find Windows pretty impressive for what it is. Check build. There is a special internal debug version of Windows called check build, externally only available for Windows 8.1 and earlier with an MSDN operating system subscription. It is a recompilation of the Windows source code with a compile time flag defined called debug, which causes compile time, conditional debugging, and tracing code to be included. Also makes it easier to understand machine code, post-processing of the Windows binaries to optimize code layout for faster execution is not performed. See the section debugging performance optimized code and the debugging tools for Windows help file. The check build was provided primarily to aid device driver developers because it performs more stringent error checking on kernel malfunctions called by device driver or other system code. For example, if a driver or some other piece of kernel mode code makes an invalid call to a system function that is checking parameters such as acquiring a spin lock at the wrong interrupt request level, the system will stop execution when the problem is detected rather than allow some data structure to be corrupted and the system possibly crash at a later time. Because a full check build was often unstable and impossible to run in most environments, Microsoft provides a check kernel and HAL only for Windows 10 and later. This enables developer to obtain the same level of usefulness from the kernel and the HAL code that they interact without having to deal with without dealing with the issues that a full check build would cause. This check kernel and HAL pair is freely available through the WDK in the debug directory of the root installation path. For detailed instruction on how to do this, see the section installing just the checked operating system and how in the WTK documentation. Yep, I mess with the AD and LDAP stuff daily. It's neat how they create such integrated system for purples. No wonder MS is leading for big companies. Yeah, I mean, for AD, you know, things like that just doesn't really exist on Linux, or at least I think. I may be pulling this out my ass. I'm also have limited knowledge on Linux, but as far as I know, the whole AD and Forest is all really well implemented on the server side of things. That said, lateral movement is also fairly easy because of it. If you manage to get domain admin. Determining if you are running the check build. There is no built-in tool to display whether you are running check build or retail build, called free build of the kernel. However, this information is available through the debug property of the Windows Management Instrument under the Win32 operating system class. By the way, use WMI sparingly, because every time you make a WMI call, it's gonna have to go through the WMI interfacing process, and calling WMI related stuff is not cheap. So, ideally, if possible, try to retrieve whatever you're looking for from the natively available Win32 API, if possible. The following PowerShell script displays this property. You can try this by opening a Windows PowerShell script host. So the get WMI object commandlet, I usually wouldn't recommend using that anymore, especially if you're on a modern Windows system. Starting from E5, I believe, and all of the PowerShell core editions, you can use get sim instance instead. Get sim instance is way faster, and while providing more or less the same functionality. Basically, get a WMI object should be considered legacy at this point. The system is not running check build because the debug property here shown says false. Much of the additional code in the check build binaries is the result of using assert and or anti-assert macros, which are defined in the WTK header file wdm.h and documented in the WDK documentation. These macros test a condition such as the validity of the structure or parameter. If the expression evaluates to false, the macros either call kernel mode function RTL assert, which calls debug print x to send the text of the debug message to the debug message buffer, or issue an assertion interrupt, which is interrupt 0x2b on x64 and x86 systems. If a kernel debugger is attached and the appropriate symbols are loaded, the message is displayed automatically, followed by a prompt asking the user what to do about the assertion failure, whether to breakpoint, ignore, terminate process, or terminate thread. If the system wasn't booted with the kernel debugger, using the debug option in the boot and the BCD, and no kernel debugger is currently attached, failure of an assertion test will bug check or crash the system, i.e. Show a blue screen. For a small list of assertion checks made by some of the kernel support routines, see the section check build asserts in the WTK documentation. Although note that this list is unmaintained and outdated. This check build is also useful for system administrators because of additional okay. Love the rocks. Actually, let's take a nap here first. Okay. The check build is also used for system administrators because of additional detailed informational tracing that can be enabled for certain components. For detailed instructions, see the Microsoft KB article number 314743 titled How to Enable Verbose Debug Tracing on Various Drivers and Subsystems. This information output is sent to an internal debug message buffer using debug print x function referred to earlier. To view debug messages, you can either attach a kernel debugger to the target system, which requires booting the system into debugging mode, or use the debug print command while performing local kernel debugging, or use the debug view tool from system kernels. Most recent versions of Windows have moved away from this type of debug output, however, and use a combination of either Windows preprocessor tracing, or WPP, or trace logging technology, both of which are built on top of event tracing for Windows, ETW. ETW is very important if you want to figure out basically anything about what the Windows system is doing. The advantages of these new logging mechanisms is that they're not solely limited to the checked versions of components, especially useful now that a full check build is no longer available, and can be seen using tools such as Windows Performance Analyzer, or WPA, formerly known as Xperf, or Windows Performance Toolkit, TraceView from WTK, or the WMI print extension from the kernel debugger. Finally, the check build can be useful for testing user mode code because of the timing of the system is different. This is because additional checking taking place within the kernel and the fact that the components are compiled without optimizations. Often, multi-threaded synchronization bugs are related to specific timing additions. By running your tests on a system running a check build, or at least checked kernel and how, the fact that the timing of the whole system is different might cause latent timing bugs to surface that do not occur on a normal retail system. Alright, time for something that I should actually read into a little bit more. Virtualization-based security architecture overview. So this will, I believe, will be covered in chapter 7 as well, but this is just like a brief rundown. As you saw in chapter 1, and again in this chapter, the separation between user mode and kernel mode provides protection for the OS from user mode code, whether malicious or not. However, if an unwanted piece of kernel mode code makes it into a system because of yet unpatched kernel or driver vulnerability, or because the user was tricked into installing a malicious or vulnerable driver, the system is essentially compromised because all kernel mode code has complete access to the entire system. The technologies outlined in chapter 1, which leverage the hypervisor to provide additional guarantees against attacks, make up a set of virtualization-based security, also known as VBS capabilities, extending the processor's natural privilege-based separation through the introduction of virtual trust levels, or VTLs, beyond simply introducing a new orthogonal way of isolating access to memory, hardware, and processor resources. VTLs now also require new code and components to manage the higher levels of trust. The regular kernel drivers running VTL1, let me reread that again. The regular kernel and drivers running in VTL0 cannot be permitted to control and define VTL1 resources. This would defeat the purpose. Figure 2 dash sorry. Figure 2-3 shows the architecture of Windows 10 Enterprise and Server 2016 when VBS is active. You'll also sometimes see the term Virtual Secure Mode or VSM used. With Windows 10 version 16.07 and Windows Server 2016 releases, it's always active by default if supported by hardware. For older versions of Windows 10, you can activate it by using a policy or use or with the Add Windows feature dialog box, select the Isolated User Mode option. So yeah, this is basically what VBS looks like, at least when Windows 10 and Server 2016 came out. I don't know if this still holds up in 11. It should, but yeah, as you can see, there's now a VTL 0 and a VTL 1. As shown in Figure 2-3, the user kernel code discussed earlier is now running on top of Hyper-V hypervisor, just like in Figure 2-1. The difference is that with VBS enabled, the VTL1 is now present, which contains its own secure kernel running in privileged processor mode, that is Ring 0 on x86 and x64. Similarly, a runtime user environment mode, also known as Isolated User Mode, or IUM, now exists, which now runs in unprivileged mode, which is Ring 3. In this architecture, the secure kernel is its own separate binary, which is found under the name securekernel.exe on disk. As for the IUM, it's both an environment that restricts the allowed system calls that regular user mode DLLs can make, thus limiting which of these DLLs can be loaded, and a framework that adds a special secure system calls that can only be executed under VTL1. These additional system calls are exposed in a similar way as regular Windows system calls, through an internal system library named lumdll.dll, basically a VTL1 version of ntdll.dll, and a Windows subsystem facing library named lumbase, or the VTL1 version of kernel base. This implementation of isolated user mode, mostly sharing the same standard with Win32 API libraries, allows for a reduction of memory overhead of VTL1 user mode applications, because essentially the same user mode code is present as in their VTL0 counterparts. As important note, copy on write mechanisms, which you'll learn more about in Chapter 5, prevent VTL0 applications from making changes to binaries used by VTL1. Okay, that wasn't too bad. Okay. I'm gonna take a tiny little break. Right back. Also, I kind of want to change a different piece of music. Let's see. What other options do I have for music without getting me copyright claimed? Give me a second while I look through my music library. God, I wish I could play opera music. Celeste. Celeste is good. Alright, I'll be right back. All right, I have returned. Okay. Right. Okay. With VBS, the regular sys user versus kernel rules apply, but now augmented by VTL's considerations. In other words, kernel mode code running at VTL 0 cannot touch user mode running at VTL 1 because VTL 1 is more privileged. Yet, user code running in VTL 1 cannot touch kernel mode running in VTL 0 either, because user ring 3 cannot touch kernel at ring 0. Similarly, VTL 1 user mode application must still go through regular Windows system calls and their respective access checks if they wish to access resources. Okay, apparently an ad break is coming up by Twitch. Well, I should have run the ad when I was away. Well, it's alright, we'll take a tiny little break again. Or rather than breaks, I guess we can just have a little chat instead of actually me going away. Gonna start soon. Oh, nice flip. Oh, okay, the back of the trunk part fell off. The trunk hood? What do we call it? You know, I'm surprised this thing doesn't need a coolant. At least I think. I'm not seeing a coolant part. Probably add the oil back though. Which one of these is oil? No, that's milk. Yeah, that thing has oil. The problem is it's kind of stuck there. Milk can be oil for a short period of time. I'm sure it could. But I'd rather just get this milk out. Yeah. I wish I could remove the seat. Oh, I could just turn off collision. Okay. There we go. How's the oil doing? Or gas? They're doing fine. Gas. Well, AFK farming MC. Nice. Okay. Okay, the ad stopped. Okay. Now we can get back to reading. I swapped my C drive to on my laptop from 256 gigabytes to 2 terabytes. Oh, that's nice. That's a huge improvement. What happened to the dashboard? Where did that go? I mean, it's not a big deal, but okay. Oh yeah, I should probably sleep. Hang on. Can't sleep yet? Okay. Well, guess we'll have to wait a little bit more. Okay. Okay. A simple way of thinking about this is as follows. Privilege levels, user versus kernel, enforce power. VTLs, on the other hand, enforce isolation. Although a VTL1 user mode application is not more powerful than a VTL0 application or driver, it is isolated from it. In fact, VTL1 applications are not just more powerful and in fact, VTL1 applications aren't just not more powerful. In many cases, they're much less so. Because the secure kernel does not implement a full range of system capabilities, it handpicks which system calls it will forward to the VTL0 kernel. Their name for the secure kernel is a proxy kernel. Any kind of I/O, including file, network, registry-based, is completely prohibited. Graphics, as another example, are out of question. Not a single driver is allowed to be communicated with. So I still don't really understand how VBS interacts with our day-to-day system work. I get the concept, but like, when is it actually used and for what things? Okay. Gonna glide a little bit and take a sleep. Or just, yep. Sure. Okay. That's, We slid a little bit too far. Okay, so we're there. So take that route. Okay. The secure kernel, however, by both running at VTL1 and being kernel mode, does have complete access to VTL0 memory and resources. It can use the hypervisor. Okay. Hang on. I love how the wheel can just pop off like that. Right, as I was saying. Right, close that window. I mean, door. It can use a hypervisor to limit the VTL0 access to certain memory locations by leveraging CPU power, CPU hardware support known as second level address translation, or SLAT. SLAT is the basis of credential guard technology, which can store secrets in such location. Similarly, the secure kernel can use SLAT technology to interdict and control execution of memory locations such as key covenant of device guard. A key covenant to of device guard. I'm starting to have trouble reading apparently. Or I think I've been having trouble speaking rather than reading. To prevent normal device drivers from leveraging hardware devices to directly access memory, the system uses another piece of hardware known as the I/O management, such as the I/O memory management unit, also known as MMU, which effectively virtualizes memory access for devices. This can be used to prevent device drivers from using direct memory address, also known as DMA, to directly access their hypervisor and the secure kernel's physical region of memory. This would bypass SLAT and because no virtual memory is involved. Because the hypervisor is the first system component to be launched, by the bootloader, it can program the SLAT and the IOMMU as it sees fit, defining the VTL0 and 1 execution environment. Then, while in VTL1, the bootloader runs again, loading the secure kernel, which can configure a system further to its needs. Only then is the VTL dropped, which will see the execution of the normal kernel, now living in its VTL0 jail, unable to escape. I love the use of the word jail there. Oh, I see something over there. Alright, I need to take a sip of my water. Come on, get me up there. You can do it. Okay. Patiently waits for the tailed chicken jockey redeem. Okay, so blank. Can you remind me after stream? Because I keep forgetting. I said last time that we were gonna add more redeems, but every time I'm like, I keep forgetting what redeems I'm adding exactly. Hair toggle redeem? Okay, yeah. Got it. Okay, we got a smaller car there. It's fine. We don't really need another car right now. That Minecraft. Whoever's Minecraft OC this is keeps jump scaring me. Ooh, no one here. That's a lot of stuff. Okay. Milk. I'll be drinking these expired milk, thank you. Man, that's a lot of car parts. I think that's a worse engine. Gas. Okay. Oil. How are we doing on oil? Okay, could use some extras. Okay. I'll close that. A 100% blood. That's a lot of blood. 1.2 liter of blood? Okay. Very normal thing to have, of course. Okay. Blood bank. More blood. I mean, I'm sure we can add blood to our gas, right? Surely. By the way, someone needs to remind me. Or rather, I should probably add the Doom game, the new one, on my calendar. I keep forgetting when it's gonna. Okay, we are taking this. Thank you very much. Hell yeah. I'm sure a tiny bit of diesel will be fine, right? You know, just a little contamination. That'll be fine. They can't even fit? Watch this. Now it fits. Huh? Okay, more blood. More funny sunglasses. Or rims. I don't know if this engine is necessarily better. Like, I think it's actually smaller than the one we have. Right? Yeah. Yeah, this engine definitely looks more sophisticated. Rusty fridge. I don't think we can do anything with the TV, fortunately. Okay, is there anything we can use inside here? Could probably use a new tire, but nah. Oh, I forgot we have a trunk at the front. Huh. I always thought it was the engine. Apparently not. I mean, I knew the engine was on the back, but so. Nice coffin. Nothing inside. Ooh, is that an AK? I don't need it though. More oil. Okay. More blood. Okay, we can't sleep here, unfortunately. How do I get up again? There we go. Anything we can take from here? Guess not. You can't sleep yet, but I also don't want to drive in the middle of no, this time. I wish I could get up there somehow. Oh, never mind. I could. A sled. Another fridge. What's all these rusty fridges? What's a poop button again? B? Okay. Oh, okay, my key is stuck again. God damn it. Save? Okay, we probably should save anyways. There we go. Okay, I'm gonna wait until I can sleep, and then we'll continue. Give it a little bit. Okay, there we go. Now we can sleep. Okay. Let's double check we have close everything. We have. Okay. Okay. Because user mode processes running in VTO1 are isolated, potentially malicious code, while not able to exert greater influence over a system, could run. I have no idea how to pronounce that word. Surreptitiously attempt secure system calls, which would allow it to seal or sign its own secrets, and potentially cause bad interactions with other VTOM processes or the smart kernel. Ooh, that's a huge rock. As such, only a special class of specially signed signatures, specially signed binaries called trustlets, are allowed to execute in VTO1. Each trustlet has a unique identifier and signature, and a secure kernel has hard-coded knowledge of which trustlets have been created thus far. As such, it is impossible to create new trustlets without access to the secure kernel, which only Microsoft can touch. Existing trustlets cannot be patched in a way which would void the special Microsoft signature. For more information on trustlets, see Chapter 3. The addition of secure kernel and VBS is an exciting step in the modern OS architecture. With additional hardware changes to various buses such as PCI and USB, it will soon be possible to support an entire class of secure devices, which when combined with a minimalistic secure Hall, secure plug-and-play manager, and secure user mode device framework, could allow certain VTL1 applications direct and segregated access to specially designated devices, such as biometric or smart card input. New versions of Windows 10 are likely to leverage such advances. Trustlet is such a funny word, sounds fake. Yeah, well, I don't even know what they are yet. We'll see. Key system components. Now that we've looked at the high-level architecture of Windows, let's delve deeper into the internal structures and the role each key OS component plays. Figure 2-4 is a more detailed and complete diagram of the core Windows system architecture and components than what was shown in Figure 2-1. Now that still doesn't show all the components, network in particular, which is explained in Chapter 10, Networking in Part 2. So yeah, it's you can see there are a lot more additional stuff like process manager, memory manager, etc. And yeah, SVC host, as a service host, regular applications, system-based processes, environment subsystems, so that includes the CSRSS and the system manager, etc. The following sections elaborate on each major element of this diagram. Chapter 8 in Part 2 explains the primary control mechanism the system uses, such as the object manager, interrupts, and so forth. Chapter 11, Startup and Shutdown, in Part 2 describes the process of starting and shutting down Windows. In Chapter 9 of Part 2, details management mechanisms such as registry, service processes, and WMI. Other chapters explore even more detail and internal structure and operation of key areas such as processes, threads, memory management, security, L manager, storage management, cache manager, and NTFS and networking. Whoa, okay. It's really hard to look at the road and then have to pick up a bottle of water and then control the game at the same time. Love how no one acknowledged that sick front flip. I mean, it's, it wasn't anything bad. Oh. The game is like in slow motions right now. What's going on? Okay. Yeah, I'm just glad it didn't like flip out, famous last words. I wonder what speed we're going at right now. Our speedometer kind of just flew out somewhere earlier, so I have no idea what speed we're at. Woo! Okay. Woo! Okay, we're doing okay. Okay. Environment subsystem and subsystem DLLs. The role of an environment subsystem is to expose some set of... Hang on. I want to double check. Is everything still here? Okay. Okay. Because we're going this way. The role of an environment subsystem is to expose some subset of the base Windows executive system services to application programs. Each subsystem can provide access to different subsets of the native services in Windows. This means some things can be done from an application built on one subsystem that can't be done by an application built on another subsystem. For example, a Windows application cannot use the SUA fork function. Each executable image is bound to one and only one subsystem. When an image is run, the process creation code examines the subsystem type code in the image header so that it can notify the proper subsystem of the new process. This type code is specified under the subsystem linker options in the Microsoft Visual Studio linker, or through the subsystem entry in the linker system property page in the project's properties. Alternatively, it is also in the P header. You can find that in the cough section, I believe. I think. Okay, let's check this place out. Okay. Still don't know what these are, by the way. Drink? Why is the left mouse button green? I'm holding down left mouse. There's nothing happening. Okay, there's a whole lot of nothing here. Wow, thanks. Don't think this pump works either. Okay. As mentioned, user applications don't call Windows system services directly. They go through one or more subsystem DLLs. These libraries export the document interface that the programs linked to that subsystem can call. For example, the Windows subsystem DLLs, such as kernel 32, ADB API 32, users 32, GDI 32, etc., implement the Windows API functions. The SUA subsystem DLL, or PSX DLL, is used to implement the SUA API functions on Windows version that supported POSIX, that is, which is none of the modern systems. Viewing the image subsystem type, you can see that through the depends.exe, or use anything that can read the P header. That'll do as well. When an application calls a function in a subsystem DLL, one of three things can occur. The function is entirely implemented in user mode inside the subsystem DLL. In other words, no message is sent to the environment subsystem process, and no Windows executive system services are called. The function is performed in user mode, and results are returned to the caller. Examples of such functions include getCurrentProcess, which always returns -1, a value that's defined to refer to the current process and all process-related functions, and get current process ID. The process ID doesn't change for a running process, so the ID is retrieved from a cache location, thus avoiding the need to call into a kernel. Okay, let's see what's over here. Guys, I have bad news. We've been here. That means we did a loop-a-loop. Okay, that's bad. Okay, let's try back. That is the first time we've definitively experienced a loop somewhere. Okay. At least we know now, though, this can happen. I'm sure this is gonna take, oh boy, I wonder how much of this is gonna throw people off and what the average playtime is for this game now. Windows internal so good you can't focus on the road. So the thing is, I'm pretty sure we didn't just like, it's not like we drove the wrong way around. I think what happened is, you know, those intersections on the road, I think one of the intersections actually led us back to where we were. I think that's the most likely scenario because, like, I'm pretty sure we hadn't been to that hut yet. Hadn't. So, I want to drive back. For some reason, my restores MBR instead of GPT. You got boot error. It's probably because your previous. I don't know. It kind of depends on what you're using. But yeah, just use GPT these days. Okay. The function requires one or more calls to the Windows executive. For example, Windows read file and write file functions involve calling the underlying internal and documented, let me guess, unt-create file. Oh, no, Windows unt-read file and write file. Create file creates the handle, and read writes the file. Of course, that's not related. What am I thinking? Oop. Come on. On you go. Thank you. And undocumented. For user mode, use Windows IO system services, Windows unt-read file, and unt-read write files, respectively. By the way, when you refer to unt-create file, read file, write file, they don't necessarily mean like file in like a file on a file system sense. So you can actually use it to write to, I believe, sockets as well. Kind of like how fopen works on Linux, I think. But by the way, what is our road? What is our flow light? What is it called? The light at the front? Called? And why is that not on? Headlight. That's what I was thinking of. What happened to our headlight? Why is it not turning on? Also, why are we sideways now? What? Okay. Where the frick are we? I can't see anything. Can I sleep first? Oh, I think we're up there. Right. Okay. So Oh, our headlights popped off some time ago. What the heck? When did they go? When and where did they go? Well, let's try to find a headlight next time. Fell off at the desert mansion? Were they? Oh, either way. You have to go find it again. The function requires some work to be done in the environment subsystem process. The environment subsystem process running user mode are responsible and for maintaining the state of the client applications running under their control. In this case, a client server request is made to the environment subsystem via an ALPC described in Chapter 8 in Part 2. Message sent to the subsystem to perform some operation. The subsystem DLL then waits for a reply before returning to the caller. Some functions can be a combination of second and third item listed, such as the Windows create process and exit Windows X function. Subsystem startup. Subsystems are started by the session manager as the SMSS process. The subsystem startups information is stored under HQLM, system, current control set, control session manager, subsystems. Figure 2-5 shows this value under this key under a Windows 10 Pro snapshot. Yep, as you can see, there's kernel mode, optional, required, Windows, etc., etc. The required value lists the subsystem that loads when the system boots. The value has two strings, Windows and debug. The Windows value contains the file specification of the Windows subsystem, csrss.exe, which stands for Client Server Runtime Subsystem. Debug is blank. This value has not been needed since Windows XP, but the registry value is kept for compatibility, and therefore does nothing. The optional value indicates optional subsystems, which in this case is blank as well because SUA is no longer available on Windows 10. If it was, a data value of POSIX would point to another value pointing to the PSXSS, or the POSIX subsystems process. I guess we'll go this way. A value of optional means loaded on demand, which means the first time a POSIX image is encountered, the registry value came. Okay, no. Uh oh. I mean, it could be worse. Yeah, it could be worse. I'll take that. I laughed so hard if everything just fell off. Thankfully, you didn't. Thankfully. There we go. Okay, move. Guys, I think our car is stuck. Pushing is not doing anything. Okay, when there's the last autosave? Five minutes ago, apparently? Oh, no. Okay, let's try to load this. Okay, this was when we checked our front light. Headlight. Okay. That's not awful, I think. Okay. The registry value K mode contains the file name of the kernel mode portion of the Windows subsystem. Win32k.sys later explain in this chapter. Let's take a closer look at the Windows environment subsystems. Windows subsystem. Although Windows was designed to support multiple independent environment subsystems, from a practical perspective, having each subsystem implement all the code to handle windowing, display I/O would result in a large amount of duplication of system function that would ultimately negatively affect both system size and performance. But because Windows was the primary subsystem, the Windows designer decided to locate these basic functions that there and have other subsystem call the Windows subsystem to perform the display I/O. Thus, the SUA subsystem calls services in the Windows subsystem to perform display I/O. Love when the game physics just lags a little bit. As a result of this design decision, the Windows subsystem is a required component for any Windows subsystem. As a result of this design decision, the Windows subsystem is a required component for any Windows system, even on-server system with no interactive users logged in. Because of this, the process is marked as a critical process, which means if it exits for any reason, the system crashes. Okay, let me take a little sip first. Ooh. Okay. The Windows subsystem consists of the following major components. For each session, an instance of the environment subsystem process, or CSRSS, loads 4 DLLs. Base server.dll, win server.dll, SSX server.dll, and CSR server.dll. That contains support for the following. Okay. For the following. Give me a second. Really, front. Don't go anywhere. No. Okay, thank you. Okay, as I was saying, right, so we're going right side. Give me a second. Save. Okay. Various housekeeping tasks related to creating and deleting processes and threads Shutting down Windows application through the exit Windows EXI API, containing .ini to registry location mappings for backwards compatibility. Sending certain kernel notification messages, such as those from the Windows Plug and Play Manager. Okay, I mean, everything's still intact. That's fine. Let's just have to drive from down here. From the Plug and Play Manager to Windows application as Windows messages. Hello? Come on, you can do it. Come on. Come on, stop stalling. You can do it. Almost. God damn it. I'm glad I saved. Right. Such as those from the Plug and Play Manager to Windows applications as Windows messages. Portions of support for 16-bit virtual DOS machine or VDM processes. That's only for Windows 32-bit. Side-by-side or SSX, Fusion and Manifest cache support. Several natural language support functions to provide caching. Perhaps most critically, the kernel code that handles... Note. Perhaps most critically, the kernel mode code that handles raw input thread and desktop threads, responsible for the mouse cursor, keyboard input, and handling of the desktop window, is hosted inside threads running inside winserver.dll. Additionally, the CSRSS instance associated with the interactive user session contain a 50LL called a canonical display driver, also known as the CDD. CDD is responsible for communicating with the DirectX support in the kernel. See the upcoming discussion on each vertical refresh to draw the visible desktop state without traditional hardware accelerated GDI support. Kernel mode device driver, or also known as Win32k.sys, that contains the following. The window manager, which controls window displays, manages screen outputs, collects input from keyboard, mouse, and other devices, and passes user messages to applications. The graphics device interface, GDI, which is a library of functions and for graphics output devices, and include functions for line, text, and figure drawing for graphics manipulation. Wrappers for DirectX support that is implemented in another kernel driver, DXG kernel.sys. So whenever you see Win32k.sys in your blue screen, it's typically related to the graphics related stuff. Typically, anyways, not necessarily. You have to check the actual stack. The console host process, also known as conhost, which provides support for console or character cell applications. On Windows, there's also, instead of using conhost, you can now also use free console, which is the thing that Windows Terminal uses. The desktop window manager, also known as DWM.exe, which allows for compositing visible window rendering into a single surface through the CDD and DirectX. And then there's the subsystem DLLs, such as kernel32.dll, ADB API, etc., that translate documented Windows API function into the appropriate and undocumented for user mode, kernel mode system service calls, and NTLS kernel.exe and Win32k.sys. Have we seen that mentioned before? I'm a little concerned that if we have. Okay, I've been here. Okay, we definitely are in a loop somewhere. This is not good, guys. We might have wasted like quite a few minutes of driving. Instead of taking it straight, let's go this way. Oh. This way. Graphics device drivers for hardware-dependent graphics display driver, printer drivers, and video mini port drivers. Note, as part of a refactoring effort in the Windows architecture called MinWin, the subsystem DLOs are generally composed of specific libraries that implement API sets, which are linked together in the subsystem DLO and resolved using a special redirection scheme. For more information on this refactoring, see image loader in chapter 3. What the hell happened to the road here? Okay, it's like partially taken up by this huge rock. You're kind of big, big guy. Gonna have to wrap around. Okay. Okay, kids, stop vibrating. Shh. Oh. Successfully swapped the SSD? Sounds good. Windows 10 and Win32k.sys. The basic window management requirement for a Windows 10 based device vary considerably depending on the device in question. For example, a full desktop running Windows needs all the window manager capabilities such as resizable window, owner windows, child window, and so forth. Windows Mobile 10 running on phones or small tablets doesn't need many of these features because there's only one window in the foreground and it cannot be minimized or resized. Same goes for IoT devices, which may not even have a display at all. So, one thing I'm surprised that hasn't been touched on in this article or in this book much is the Xbox subsystem. It technically runs on the same Windows subsystem as well, I believe. It was like briefly mentioned, like one sentence or two, I believe, but like that was about it. Kind of hoping we'd see some more Xbox cameo here. For these reasons, the functionality of Win32k.sys has been split among several kernel modules so that not all modules may be required on the specific system. This significantly reduces the attack surface of the window manager by reducing the complexity of the code and eliminating many of its legacy pieces. Here are some examples. So on phones, you've got Win32k that loads Win32k min and Win32k base. On full desktop, it loads Win32k base and Win32k full. On certain IoT systems, you might even only need the base part. Oh, hello.
Please, I am just hungry.
Yeah, I know you're hungry.
Want to eat?
Yeah. Okay, at least I know we haven't been here yet.
My legs are not so good, so please stop. I want to take a look at you.
Yeah. I'm gonna get my shovel out. I was gonna say, can you run him over? Apparently not. Here we go. Anything useful here? Aside from food. Okay, there's a hand. That's not food. Uh-huh. Oh, I see a hidden oil. Yes. Oil. Oh. That's what I get for having the shovel on hand. God damn it. Well, glad it just auto-saved recently. Oh my god. Amazing move, thanks guys. Okay. Stop having... Okay. Yeah. Let's not have our shovel out this time. Okay. As I was saying, or doing... use the gas. Okay. Oh, wrong button. Okay. Applications that call the standard user functions to create user interface controls, such as windows and buttons on the display. The window manager communicates these requests to the GDI, which passes them to the graphics device drivers, and they are formatted for a display device. A display driver is paired with a video mini port driver to complete the video display support. I cannot see anything. We might need to take a nap here. Are we at Disneyland yet? I wish. So welcome to the stream. Okay. The GDI provides a set of standard two-dimensional... Hello? Oh, it's moving slowly, surely. Oh, okay. Come on, we got this. The GDI provides a standard two-dimensional functions that let applications communicate with graphics devices without knowing anything about the devices. Whoa, really? Really? Oh my god. You sound so depressed, stream parent. That's because we're not at Disneyland yet. Also, we just discovered not too long ago that we were in a loop. We revisited places that we saw before. Also, I'm tired. There's also that. Where's the road? Oh, I see it. Okay. Okay. How's the road looking? Okay, this looks fine. Okay. GDI function mediate between application and graphics devices such as display drivers and printer drivers. The GDI interprets application requests for graphics output and sends a request to graphics display drivers. It also provides a standard interface for applications to... Are you serious, dude? Another one? Bro. Well, time to wrap around again. It also provides a standard interface for applications to use varying graphics output devices. This interface enables application code to be independent of the hardware devices and their drivers. The GDI tailors its messages to the capabilities of devices, often dividing the request into manageable parts. For example, some devices can understand directions and to draw an ellipse. Others require the GDI to interpret the command as a series of pixels placed at certain coordinates. For more information about the graphics and video driver architecture, see Design Guide for the section of Display, Adapters, and Monitors chapter in the WDK. Because much of the subsystem, in particular, display I/O functionality runs in kernel mode, only a few Windows functions result in sending a message to the Windows subsystem process. Process and the thread creation and termination and DOS device driver letter mapping, such as through subst.exe. I've never heard of that one. Alright, I need to scroll down, but I need to get off this peak first. And this is one in rocky terrain. I'll continue once I get off this ramp, because this ramp is kind of scary. Okay. In general, a running Windows application won't cause many, if any, context switches to the Windows subsystem process, except as needed to draw a new mouse cursor position, handle keyboard input, or render screen through CDP. Console window host. In the original Windows subsystem design, the subsystem process CSRSS was responsible for managing console windows and each console application, such as cmd.exe, the command prompt. Alright, I'm thinking we go right. But that loops back to right. You know what? Okay, fine. We'll go left. Make a right and then left and then right and then left. Okay, we could do that. I just gotta remember which one I did last time. I feel like this one is also hitting back. Is it not? I feel like this one also heads back. Apparently we're leaking somewhere. Hang on. Let me double check. Oh, god damn it! I didn't close the cap again. Was it an empty one? Yeah, here. How much does this have? Let's use that real quick. Okay. Close the cap. Thank you. No, no. Thank you. Okay, let's get back to the intersection again. Okay, let's try this side instead. Starting with Windows 7, a separate process is used for for each console window on the system. The console window host, also known as conhost.exe. A single console window can be shared by multiple console applications, such as when you launch a command prompt from the command prompt. By default, the second command prompt shares the console window of the first. The detail of the Windows 7 console hosts are explained in Chapter 2 of the 6th edition of this book. I believe conhost is now kind of legacy now, since free console exists now. I think. With Windows 8 and later, the console architecture changed yet again. The conhost.exe process remains, but is now spawned from the console-based process rather than from CSRSS by the console driver. There's a console driver? I didn't know that. From the condrive.sys. The process in question communicates with conhost using console driver by sending read-write IO control and other subsequent other IO request types. Conhost.exe. Okay, so we went left last time. No, we went right this time. Next time. Last time. This way? Conhost.exe is designated as a server, and the process using the console is a client. This chain obviates the need for CSRSS to receive the keyboard input or the raw input thread and send it through Win32K to console host, and then use ALPC to send it to command. Instead, the command line application can directly receive input from the console driver through the read-write IOs, avoid needless context switching. The following process explorer screen shows the handle conhost.exe holds open the device object exposed by condrive. That's why it's named /device/condrive. For more details on device names and IO, see Chapter 6. Notice that the conhost is a child process of the console process, in this case cmd.exe. Conhost creation is initiated by the image loader for the console subsystem image, or on demand if the GUI subsystem image calls the allo console Windows API. Of course, console and GUI are essentially the same in the sense that they're both variants of this Windows subsystem type. The real workhorse of conhost.exe is the DLL loads, also known as the conhost v2.exe .dll, and includes the bulk of the code that communicates with the console driver. So, okay, so we went straight. Okay, I'm glad nothing flew out there. We went straight last time. I guess we're going right this time. Also, I see a shed. I hope that I haven't seen that shed yet. Haven't. Oh, yep, we have not seen this shed yet. Let me just get off the road a little bit. Alright, goodbye. Thank you. Whew. Okay. Just a reminder, I think we started on page 39 today, or 38. We're currently at page 68 now. So actually, I think we're slightly slower. No, we're not. I think we're not slower because, you know, the first few pages were... Alcohol, you say? Okay. Yeah, the first few pages were table of contents and whatnot, so... More alcohol. Bats. Okay. Gas. And gas. There we go. Oh, I've been streaming for 4 hours, damn. Yeah, it's the middle of the day for me, yeah. Oh, does this cat, does this thing have cat? No, it doesn't, okay. Even though it's the middle of the day for me, I already feel tired just from all the reading. Oh, there is cap, okay. Save real quick. Does it say how long we've been driving, by the way? Which one is the current save? Ah, this one. Okay, we've been driving for 141 kilometers, apparently. Wherever this is. What? Okay. Was it like fuel tank or something? I'll take that, I guess. I think that's it. Okay, let's take a nap before we go. So we're still on the lookout for another car so we can have our headlight back. Okay. Other subsystems. As mentioned, Windows originally supported POSIX and right, so it's gonna go right. We went straight last time. As mentioned, Windows originally supported POSIX and OS2. Because these subsystems are no longer maintained or are no longer provided by Windows, they're not covered in this book. The general concept of subsystem, however, remains, making the system extensible to new subsystems if such need ever arises in the future. Pico providers and Windows subsystem for Linux. So this section, take it with a grain of salt because that's not going to apply to WSO2 anymore. This is more or less for WSO1. So the way WSO works is it's still run on top of Windows, but with it's more like a Linux kernel living inside Windows. With WSO2, it's a fully dedicated Linux kernel running in parallel of Windows. That's basically the gist of it. And this this book only covers the early iteration of WSL. Pico providers and Windows subsystem for Linux. The traditional subsystem model, while extensible and clearly powerful enough to have supported POSIX and OS2 for a decade, has two important technical disadvantages that made it hard to reach broad usage for non-Windows binaries beyond a few specialized use cases. As mentioned, because the subsystem is okay, nice flip. Because because subsystem information is extracted from the PE header, requires the source code of the original binary to rebuild it as a Windows PE executable file. This will also change any POSIX style dependencies and system calls into Windows style imports of a PSX DLL library. It is limited by the functionality provided either by the Windows Win32 subsystem, on which it sometimes piggybacks, or the kernel. Therefore, the subsystem wraps instead of emulates the behavior required by POSIX. Okay. This is fine. This is manageable. Right? Just a few wheels blew off. No big deal. Okay. This can sometimes lead to subtle compatibility flaws. Finally, it's also important to point out that, as the name says, nice flip. I love constantly having to reattach the hood, the trunk hood. That, as the name says, the POSIX subsystem SUA was designed with POSIX Unix applications in mind, which dominated the server market decades ago. Not true Linux applications, which are common today. Solving these issues required a different approach to building a subsystem, one that did not require the traditional user mode wrapping of the other environment system call and the execution of traditional P images. Luckily, the Drawbridge project from the Microsoft Research provide the perfect vehicle for an updated take on subsystems. It resulted in the implementation of the Pico model. Under this model, the idea of a Pico provider is defined, which is the custom kernel mode driver that receives access to specialized kernel interfaces through the PS registered Pico provider API. The benefits of these, apparently the cacti are destructible, to these specialized interfaces are twofold. They allow the provider to create, god damn it, stop with the tiny rocks. They allow the provider to create Pico processes and threads while customizing their execution context, segments, and store data. God damn it. Yeah, I need like a counter on how many times the trunk has been flipped open. Which way were we facing? I lost track. Chat? Yes. Okay. Which way were we facing? Before I stopped the car? Is it just straight that way? Now let me check the VOD. Straight, I think, yes. Okay, hang on, let me double check. No, the car got flipped. It's the wrong way. Why is my viewpoint locked? Hello? Oh. My mouse's battery died, that's why. It was like, hey, I need to be charged. Can you charge me for like the last 12 hours? I didn't charge it. That's on me. Sorry, streamer, I failed you. How dare you? Yeah, this way. Aaron died for a second. Welcome back. Where was I? While customizing their execution context, segments, and store data in their respective eProcess and eThread structures. I'm going right. Or does that go? So chat. Just in case. Save. Do you think I should just drive straight ahead? Off the road? Because I feel like the road is giving us false pathing, you know? That sounds like a terrible idea, but sure. All right, let's do it. Watch as the car spins out of control multiple times. They allow the provider to receive a rich set of notifications whenever such processes or threads engage in certain system actions, such as system calls, exceptions, APCs, page faults, termination, context changes, suspension, resume, etc., etc. What can happen? You get a flat tire. What can happen is I flip out and all my stuff fly out, which is pretty bad. With Windows 10 version 1607, one such Pico provider is present, LXSS.sys and its partner LXCore.sys. As the name suggests, this refers to the Windows subsystem for Linux component, and these drivers make up the Pico provider interface for it. Because the Pico provider receives almost all possible transitions to and from user from and kernel mode, be they system calls or exceptions, for example, as long as the Pico process or processes running underneath it has an address space that I can recognize and has code that can natively execute within it, the quote-unquote true kernel below doesn't really matter as long as the transitions are handled within a fully transparent way. As such, Pico processes running under WSL Pico provider, as you'll see in Chapter 3, are very different from normal Windows processes. Lacking, for example, the NTDL that is always loaded into a normal process. Instead, the memory contains structures such as a VDSO, a special image only seen in Linux or BSD systems. So, yeah, this is how WSO works. WSO 1 anyways. I think I'm going to skip this section because I know this part doesn't really hold up anymore. I don't know if Pico, if the concept of Pico provider still exists. It probably still does, but like, you know, the main one that is being described here, which is the WSL, is no longer here. Okay. No way, that goes in the back. Come on, slap on there. You got this. Okay. I'm gonna skip this section for now, and we're just gonna go to NDDL. Okay. NDDL. NDDL is a special system support library, primarily for the use of subsystem DLLs and native applications. Native, in this context, refers to images that are not tied to any particular subsystem. It contains two types of functions. System service dispatch stubs into Windows Executive System Services, internal support system used by subsystems, subsystem DLLs, and other native things. The first group of functions provides the interface to the Windows Executive System Services that can be called from user mode. There are more than 450 such functions, such as nt-create file, nt-set event, and so on. As noted, more of the capabilities of these functions are accessible through the Windows API. Oh, god damn it. Stop it. Like, literally, stop the car. Man, do the trunks fly off this easily? In real life, like the hoods. No, sure hope not. These cars are made by HP. Inch problem. Classic. Okay, I kind of woke up in the middle of like sundawn, sunbreak, sunrise. Okay, I can't really drive when I can barely see the road, or quote-unquote road. I mean, what's in front of me? Because there are a lot of tiny rocks. Oh, sick drift. Wicked. Surely we're gonna see the road eventually again, right? What is that? A tower? Ooh, okay. Nice flip. Okay, we got an interesting structure here. What is this? Water tower? It doesn't look like it. Okay, it's water, yeah. But, like, is anything up there? Guess not. Since we don't have to worry about hunger and water, I think we're fine. Okay. A number are not, however, and are for use only by specific OS internal components. Each of these functions, ntdlo.dlo, contains a entry point of the same name. The code inside the function contains the architecture-specific instructions that causes a transition into kernel mode to invoke the system service dispatcher. This is explained in more details in Chapter 8, Part 2. After verifying some parameters, this system service dispatcher calls the actual kernel mode system service that contains the real code inside the oskernel.exe. The following experiment shows what these functions look like. Open the version of WinDebug that corresponds with your system's architecture, for example, x64 on the 64-bit version of Windows. Then the File menu and open Executable. Navigate to System32 and open Notepad. Notepad should launch, and debugger should break in the initial breakpoint. This is very early in the life of the process, which you can witness by executing the K command, or call stack. How do people memorize these? How am I gonna instinctively think, okay, K stands for call stack? Because like it's not even like CS or whatever. It's just K. You should. They just do. The main... where am I? You should see a few functions starting with LDR, which indicates the image loader. The main function for the notepad has not executed yet. This means you won't see the notepad's window. Set breakpoint inside NT create file, inside NT DLL, by using BP and... Okay. Apparently we've got a few cacti stuck to the front of our car as well. Nope. Okay. One of these crashes, the physics is gonna shoot your tire at 1,000 kilometers an hour. I sure hope not. Good night, gang. Learned a lot of new things about Windows. Thanks, Sansa. Thank you for stopping by again. Have a good night. I think I won't read too much more of these today either. I still let me just at least finish a few more pages though. I'm thinking like another hour, another half an hour or so will be enough. Because my throat is starting to give up. Okay. So yeah, you can do BP NTDLO exclamation mark NT create file, and then you press go or F5, and debugger will continue to run. You may see function names like ZW create file. ZW create file and NT create file refer to the same symbol in user name, user mode. Why is there? What's this? What's this glow thing? Barrier? No, surely I can drive over to this, right? Yeah, I can. Oh, or not? Try again. No way I hit the world border. Surely not, right? Yeah, no. This is not world border. I was like, that's too shallow for world border. Okay, now enter the unassembled command, or U, to see a few instructions ahead. The EAX register, or extended register, is set with the system service number, or 55 hex in this case, the system service number in its OS, and then it calls the syscall. This one is causing processor to transition into kernel mode, jumping to the system service dispatcher, where EAX is used to select the NT create file executive service. You'll also notice a flag at offset 0x308 and the shared user data. If the flag is set, execution will take another path by using int to EH. Ooh, are we back at the road? Okay. Sure, I'll take this road. If you enable specific credential guard VBS feature that is described in chapter 7, this flag will be set on the machine because the hypervisor can react to the int instructions in a more efficient fashion than the syscall instruction. This behavior is beneficial to the credential guard. As mentioned, more details about this mechanism and the behavior for both syscall and int are provided in chapter 8 in part 2. For now, what was this? Okay, we haven't been here yet. here? Nope. Okay. What do we have in here? We got oil. Okay. Is that a hand? No, that's a foot. What is this? Is this an engine? To cover the lid? Oh, I guess not. That's the engine to the bus. Do you think it takes alcohol? Do you think I can retrofit this inside? No? Are you sure? Oh. Okay. Come on. We got this. Aw, really? It's not starting. No, surely we can get this to work. What am I missing? Just alcohol? Okay, can you just stop moving? Thank you. Needs oil? But where? Oh, engine can. Oh, okay. I see. I see what the problem is. Okay. I gotta get the alcohol out. Can I somehow get the alcohol out of there? I already drained it. Surely this will work, right? Wow. Someone's got their piss bottle. Piss bucket. Blood. Okay. 57 gas, oil, gas, oil. Y'all got more of that gas? Or oil somewhere? That's gas. That's gas. Like you. Oil. There we go. Let me gas that up first. Okay. What's the stuff we have back there? That's gas. Oh, apparently I can drink from the cactus. Huh. Okay. See if that works now. Come on. Oh. Okay, I don't know why it's making that sound, but it's moving. Okay. And this seems like it's moving faster. I'm still gonna take this with me, though, just in case. Yeah, just stuff everything in the trunk. I just beat a boss in Metroid. What the hell did I come back to? We installed a bus engine in our freaking... I don't even know what this vehicle counts as. Anything up here? Nope. Anything else in here? I think we're good. Let's sleep. Is a beetle in it? Yeah, that's what I was gonna call it. Yeah, probably a beetle. We're still missing headlight though, unfortunately. Okay. So it's gonna continue making that sound, unfortunately. But we're driving. I don't know why it's shifting to the right when I drive. Okay, I have a feeling this engine doesn't work as well. Because I don't think we're moving fast necessarily. Okay, hang on. Let me take this out. Thank you. Come on. Okay. Retrofit our previous engine back. Not you. You. Oh. Guess we have to say goodbye to that bus engine then, unfortunately. Okay. Back on the road. Yeah, it definitely is better than the bus engine, unfortunately. Would have been sick to gotten a engine upgrade. Okay, you saw in the virtualization-based security architecture overview section that IUM applications can leverage another binary similar to NTDLL, called ALUMDLL. Okay, hello. Okay, nothing flew out. This library also contains system calls, but their indices will be different. If you have a system with credential guard enabled, you can repeat the preceding experiment by opening the file menu in Windows Debug, choosing crash dump, and choosing LAMDLL as a file. Note how in the following output, the system call index has a high bit set. Okay. Love how this keeps happening to me. And no shared user data check is done. Syscall is always an instruction used for these types of system calls, which are called secure system calls. NTDLL also contains many support functions, such as image loader, function that starts with an LDR, a heap manager, Windows subsystem process. I'm gonna go this way. And the Windows subsystem process communication functions that start with CSR. Process communication functions. Okay. NTDL also includes general runtime library routines, functions that start with RTL, support for user mode debugging, functions that start with debug UI, event tracing for Windows, functions that start with ETW, user mode asynchronous procedure call, dispatcher, exception. APCs are explained briefly in Chapter 6, and more in detail in Chapter 8. I just realized, where's our trunk for the back? God damn it. Where'd I drop it? I just not put it back on when I replaced the engine. Chat, where I put it? Or did it pop off here when we last ran into something? No, not here. I mean, it's fine. We don't need that trunk necessarily. But hang on, let's see what the last save was. It was 5 minutes ago. Yeah, that's fine. Just load that. Alright, get out of there. No, the trunk was definitely still attached here. So, I don't know what happened there. The hood, whatever you want to call it. Okay. Okay, let's try this again. Okay, finally you'll find a small set of the C runtime or CRT routines in NTDLL. Limited to those routines that are part of the string and standard libraries, such as memcopy, string copy, sprintf, and so on. These are useful for the native application described next. Native images. Some systems, some images are executables, don't belong to any subsystems. In other words, they don't link against a set of subsystem DLLs, such as kernel DLL for the Windows subsystem. Instead, they link only to NTDLL, which is the lowest common denominator that spams subsystems. Because the native API exposed to by NTDLL is mostly undocumented, these kinds of images are typically built only by Microsoft. One example is the Session Manager process, or SMSS, described in more detail later in this chapter. Okay. Safe drift. SMSS is the first user mode process created directly by the kernel. So it cannot be dependent on the Windows subsystem because CSRSS or the Windows subsystem process has not started yet. In fact, SMSS is responsible for launching CSRSS. Another example is all check utility that sometimes launch at system startup to check disks. Because it runs relatively early in the boot process, launched by SMSS, in fact, it cannot depend on any subsystem. Here's a screenshot of SMSS and the dependency walker showing that it's dependency on NTDL only. And notice the subsystem type is indicated by native. Executive. The Windows executive is the upper layer of NT-OS kernel. The kernel is the lower layer. The executive includes the following types of functions. Functions that are exported and callable from user mode. These functions are called system services and are exported via NTDLL, such as ntCreateFile from the previous experiment. Most of the services are accessible through the Windows API or APIs of another environment subsystem. A few services, however, aren't available through any documented function, subsystem function. Examples include ALPC and various query functions, such as ntQuery information process, specialized functions such as ntCreate page, create paging file, and so on. Okay, hang on. Device drivers that are called through device IO control function. This provides a general interface from user mode to kernel mode to call functions in device drivers that are not associated with a read or write. The drivers used for Process Explorer and Process Monitor from system terminals are a good example of that, as is the console driver mentioned earlier. Functions that can be only called from kernel mode that are exported and documented in WDK. These include various support routines such as IO managers, ones that start IO, and general executive functions, EX, and more needed for device driver developers. Okay. Oh, we hit the 5-hour mark. We're gonna let the ad play, and I think I'm gonna get ready to stop. Call it here. Functions are exported and can be called from kernel mode, but are not documented in the WDK. These include functions called by the boot video driver, which starts with IMBV. Okay. I'm gonna do this. Okay. I love the flashlight just doesn't have a battery. It just always works. I guess it's not this thing how this thing doesn't have a coolant chamber. Functions that are defined as global symbols but are not exported. These include internal support functions called within NTOS kernel.dll, such as those that start with IOP, internal IO manager support functions, or MI. Internal memory management support functions. Functions that are internal to a module that are not defined as global symbols. These functions are used exclusively by the executive and kernel. The executive contains the following major components, each of which is covered in detail in a subsequent chapter of this book. There's the configuration manager. The configuration manager, explained in chapter 9 in part 2, is responsible for implementing and managing the system registry. Right. Oh, I hear him. Where are you? Here you are. Hello. Goodbye. Alright, let me stop the car real quick. Gas is looking good. Oil is fine. Alright, is there anything useful here? Hello? Oh, that was loud. Okay, a huge engine with no oil. Let's see if this runs any better. It's like larger. What do you think? Blank. Do you think that's gonna run any faster? Ow, my ear. Thanks. Way too dank. Okay, a rear view mirror. Okay. Revolver. Whatever that is. Ooh. Well, that's a decently bright flashlight. Do you think this can go in there? No. Oh, that'll be too easy. I hope that stays, because that'd be sick. Probably not, though. Okay. Time for experiment. See what happens if I do that. Well, that thing's bright. Nope. Not what I meant. It'll be fine, right? Alright, let's see if this starts. Okay, wow, okay. This is much faster, holy shit. Wow, that's fast. Woo! A little too fast. That is a much better upgrade, holy. Alright, let's see what's in here. Ooh, a different car. We don't really need it. It's missing the trunks, the hoods as well. And so it's fine. We don't really need it, but you have a headlight somewhere. No. We have blood. Nah, okay. Nothing I need. Yeah, nothing I really need. Alright. Arm. Well, so much for that. Damn it. Well, that won't start. Damn. Well, darn. I should probably pull the handbrake. Well, damn it. Really hoping to get like a really cool engine. How about this one? I don't think this one's necessarily even better, but eh. Okay. Gas plus oil. Oh, that's just oil. Okay. Yeah, let's see if this is any faster. First, let's sleep. Oh, actually, we don't need to sleep yet. Is this faster? I can't tell. I think it is. I think. Well, it has speedometer, so I can't really tell. Speaking of speedometer, I want to see if the car back there has one. Because we're missing one. Suppose I need to sleep anyways. Okay, so that's like the tail light. I'm gonna look for the headlight. No, there's no speedometer in here either. Damn. Oh, alright. I'm gonna drive a tiny little bit more, and I'm gonna call it. I'm getting tired. The configuration manager. For implementing, managing system ratio. Okay, I think we read that already. I'm gonna go straight. Process manager. Process manager, explained in chapter 3 and 4, creates and terminates processes and threads. The underlying support for processes and threads is implemented in the Windows kernel. The executive adds additional semantics and functions for these lower level objects. When was our last autosave? So the reason why I want to load that autosave is not necessarily because we tipped over, it's because I'm hearing the oil leak. Yep, that just leaked out all of the oil. Very cool. It's just EP. Understandable. Okay. Gonna redo the engine swap part again. By the way, what is this? It's like a propane tank. Is this girl still reading textbooks and fixing cars? Yeah. Almost done, though. I'm getting tired. D colon? Wow. Sick. Had a quick shower? Wait, is that metal detector? The hell? Oh my god, it's a metal detector. Or are we gonna be able to find something? Wow, guys, I found the car. Okay. Yep, you go in there. And let me get that oil tank. Come on, let me get through. Thank you. No detector won't find things on the ground? It might. Just, there's nothing here, I guess. No, not drinking. Don't drink it. It's meant for buildings, coffins, wells. Sure. Okay, save. Okay, we're gonna drive a tiny little bit. Probably until the next house or something. And then we're gonna call it. What's up with the dangerous, scary music? There's no boss here. Oh! Well, the boss is me. Or the cliff. Okay. If UFO overhead, metal detector will go crazy. Wow. Imagine it's seeing a UFO. That's what the metal detectors are for detecting UFOs. Alright, can't see anything. I'm starting to think if it's a tire that's like making me spin out more. Don't ever drive this music on, by the way. You're gonna fall asleep. You're gonna get into a car accident. Do not listen to Celeste while driving. Put on Truckers FM or something. You see, I put it on if we weren't reading a textbook. Need some Eurobeat, of course. Tell you what, for this last part, we might as well put on Truckers FM, because like we're almost done with the stream anyways. Why is it not playing anything? Hello? Music where? Mod check. Maybe their Twitch channel? No, they're not online. Oh no, wait, that's the DJ that's playing it, right? How do I actually never used Truckers FM before? Listen. Music player? On Twitch stream? No, that's for playing. That's for getting the... Oh, is it this button? Oh, it's that button.
I threw a wish in the well.
Yeah, DMCA. Woo! Okay, now the car isn't going. Are you joking? Well, man, I think anything that's not the original engine is gonna make this thing go. Like, what the hell are you doing? Where'd the engine go? Oh, there it is. Right. Reminds me of YouTube Rewind style. As much as we clown on YouTube Rewind, I kind of miss it because of how stupid it is. You can move it off screen. I can still hear it. YouTube's gonna yell at me. But it's okay, you guys are watching on Twitch anyways. Twitch is, yeah, more lenient, let's just say. It's fine. When this was still popular, I was still kind of making YTP MVs, like not as much, but you know, I definitely still made YTP MVs back in this day because there was actually a fad of people making YTP MV of the song. I can't tell if the handbrake is on or not. Let me turn this up a little bit. Is Lady Gaga? I've not listened to any Lady Gaga in a long while. Smart speaker and long drive radio is crazy. I only hate this. So I'm playing this externally on Edge, but I have to imagine there's got to be a mod or something that adds external radio support, right? I don't think I've ever listened to any Lady Gaga. So the last time Lady Gaga was relevant in my life was like in her early days, you know. Or in her mainstream days, you know, Poker Face and whatnot. Was Poker Face like 2012? Honestly, it feels much longer than that, but probably, yeah. Oh, I should probably fix that. In the movie was Poker Face. I thought it was neat. Oh. I think make a turn right. I'm not gonna read any more of the Windows internals for the next few minutes, because if YouTube yells at me, this part is probably gonna get erased anyways, and it might get erased on Twitch as well. I'm just trying to find like the next stop before we stop the stream. This is kind of good. I mean, it's fine. Like, I feel like the peak, honestly, if copyright wasn't an issue, I'd like to keep Truckers FM on while I read things. Cause like this is a lot more engaging than me EP music. Truckers FM is just generally a good time for this type of game.
You're listening to Truckers FM. Let's go through requests. Obviously, the DJ Big asked for the Spinning Cat song. Wait a minute. The CD Road Sucks asked for some Local Rainbow, so I put in Local Rainbow and Popeth with Rumours remix that came out at the end of last month.
I can barely tell what he's saying.
90s Are Cool asked for the Dave Way remix of the Spice Girls Wannabe. I put that in. The AB87 and David were both asking for Call Me Maybe by Carly Rae Jepsen. There was a request for another song by somebody else, TJ3763, asking for Run Away With Me by Carly Rae Jepsen. I don't even have that, so I couldn't play it anyway. So we're going to go into more requests now. We've got one of the most popular songs of the station coming up next. Then we've got a song by our very own presenter Tiffany Berner under her stage name Matilda Hart.
Nope.
A song from Damiano David, and a song from Sabrina Carpenter. But first, as a request from I Crash Trucks, here is one of the station's favourite songs.
Oh, god damn it. Of course. Thanks, guys. Come on, sing along. You know the rules. Ah! Do I? Thinking of any other guy. Now the MC will freak out. It'll be fine. Understand. Let you down. Desert you. By the way, you guys need to listen to Rick Astley's recent works. That's actually pretty good. I like the album 50. Or I believe he released when he was 50. Pretty good. He still sings excellent to this day. His voice is great. He's like fine wine even. Oh, okay, I see. My piece is blown out. Okay. As I was saying, I may have lost a bit of blood You'll be fine. Oh. Oh, come on. On there. On you go. Thank you. Freaking debated by the radio host. Okay. Anything interesting here? Right. Turn that off.
Your destination
Your destination.
for hit music.
Truckers FM.
Oh, they've got a headlight. Okay, let's see if we can adopt that. Hello. Alright, goodbye. Aw, really? Man stares at wall, no mercy. You know, he was gonna get to me eventually. What? I thought he was next to me. Oh man, I can't install it, really? That's lame. Alright, where's the other guy? He's upstairs. That's right, it goes in the square hole. Honestly, this looks like a decent car, but yeah, it's fine. I'll take the current one.
The biggest hits at the weekend.
This is Truckers FM.
How about get upstairs? Okay, whatever. I'm just gonna. Okay. Save. Alright, I need a little restroom break. Right back. Oh wait, not that positive music. Okay. I'm just not gonna switch to BRB screen. Let me see who I can send you guys off to. Raid, refresh. Not a fan of raiding bigger channels, right? It depends. I'm checking who I can raid. What's sci-fi streaming? I cop this bash. Hang on, let me see you. $44 viewers. What are they doing? That's an interesting way to display the code on stream. What are they writing? Click Python. No, it's not Python. Let's go dot. Yeah, it looks pretty cool. Yeah, sure. I'll send you guys over. All right, I'll see you guys later. Have a good one. Thank you guys for stopping by again.